Hi, I'm here with John Kenny, one of the old guard. Is that the correct term from HP
I guess.
days? Yeah, none of this Keysight stuff. He's an original HP guy.
40 years.
30? How many?
40.
40. Geez, you get less for murder. Sorry. No, so you're a company man.
Since college, yes.
Since college.
That's right. Right out of school.
Excellent. Well, tell us, how did you start at HP and what you do these days?
So I started at HP because I wanted to be in the audio business because I love music. And I went to the interview there and I discovered that power supplies are just like audio. Big heat sinks, power transistors, transformers, low frequency signal processing, and all my control theory came into hand. So I started designing power products for many years. Discovered I liked the firmware side of it. After a while, got into firmware. And then a lot of our firmware technology has moved into digital and FPGA, so I got into that. And then I got into management because I knew all the different areas and I could tell people they were full of it when they would tell me things.
Got it.
And from there, I went from power product management into product line management, where I got involved with the voltmeters, the function generators, the data ACK, those teams. So a lot of the products now, and I've actually done design with them because of common components. My job today is more or less, I like to think of it as somebody who moves from project team to project team all throughout the company, finding technology that someone's developed that's the best, and then transferring it through the different organizations.
Got it. So what is your title these days?
Technology and efficiency management.
Efficiency. I'm going to assume that efficiency does not mean power efficiency.
Absolutely not.
No, it means...
It means getting more products out for the same engineering. Not less products,
okay.
Not less money for the same products, more products for the same engineering. So, for example, the 34460 front panel, that design is now used in, I guess, about 6 or 7 products.
Right, so that was a deliberate push to go in that direction.
Correct. We're doing that more and more, so we make our SMUs use the same internal technology for some of those pieces as our voltmeters, as our counters, function generators. We've actually got a new, lower cost one that we use in the new power supplies, because it wasn't priced right for the price points we have to hit for power products. We actually took it down another price point, and that's going to be spread through many products in the future. Interesting.
So when did that sort of focus change? When decided, look, we need a common architecture, or has it always been around in some form?
Well, there was the original 34401 voltmeter.
Yep.
That technology spread into probably 8 or 10 products. The data ACK products were based on that. The nanovoltmeter was based on that. Believe it or not, the 3631 power supply actually has the voltmeter chipset inside of it. So they did it a long time ago, and somehow when we got the small part of a bigger company like Hewlett Packard, that stuff fell out of favor. We were starving those teams. Now we're kind of bringing back the renaissance, if you will, of these products to make them more efficient, to cover more space. And now that we're solely a test and measurement company, we're not giving all our money to start life sciences or computer companies. We're really refocusing and growing the company again. It's a lot more exciting today than it was 10, 15 years ago.
Interesting. So you started in 78?
Correct.
1978, straight out of college?
That's right.
Did they recruit you? Did they come into the colleges and recruit, or how did that happen?
They did, but I went to Lehigh University, and they didn't recruit at Lehigh. They recruited at some of the bigger schools. So luckily, the power products development was done in New Jersey, and I was born and raised in New Jersey. It was right down the road from me, so it was an easy play for me.
I didn't know they ever did anything in New Jersey.
We used to have a very large manufacturing center in New Jersey. Now it's all in Penang. We've moved everything to Penang for efficiency. I had nothing to do with that, but we've got rid of most of the U.S. manufacturing. In fact, the voltmeters were originally manufactured in Loveland, where the design team was, the power product.
I thought that was the only design group was in Loveland, really, or the main one. Where were the design centers?
Well, at its peak when we were Hewlett Packard, we had probably 30 or 40 design centers all around the world. Today, if you take the RF off the plate and the scopes, we have design centers in Loveland, we have it in Budd Lake, New Jersey, we have Penang, we have Hachiochi, and we have Singapore.
Right.
So that's everything that's not RF is done in those 5 design centers.
Very interesting. Why so many design centers back in the day? Was it
it's really
scatter the jobs around? Was it?
No. Bill and Dave were amazing guys, and one of their things that they really believed in order to foster the maximum amount of innovation, was diversity. So as soon as a site got above a certain size, they would cleave off a piece of it like a piece of dough and stick it somewhere else and let it grow into a new site. So we started organizations in Loveland, started organizations in Spokane, Washington, and then Lake Stevens. And the computer group did the same. They would get to a certain size and then they'd spin off another group in a new location near a different set of universities to get a different pool of technology.
Got it.
And that was a great thing for the day when innovation and design was really all that mattered.
Yep.
Today, it's somewhat of a blessing and a curse. And the ability for people to get efficiency compared to some of our competition, it's much more difficult because everybody does their own thing and you don't get common design, you don't get common parts, you don't get shared knowledge as much as some of our competitors who are all located in one building down in Austin or maybe in Germany somewhere. They're much more vertically integrated and they can enforce common design practices.
Right, interesting. So did you know Bill and Dave? They were still technically there in the late 70s?
They were still there in the late 70s. I met both of them once, but I was very young. I was telling Simon that my boss at the time was working on the HP 3000 computers, and Bill, he came to visit and to go over some negotiations and some technical stuff with him, and I'm sitting at my bench and all of a sudden, Dave, there's somebody I'd like you to meet, and I turn around and there's Dave Packard, all 6'5" of them, and I'm like, I didn't know what to do.
Right.
I was there for about a year when that happened. But they would come, back in the day, they would come to all the sites.
Yep.
There weren't as many, of course. They would come to all the sites once a year and visit everybody. And in fact, our CEO, Ron Nersessian, who was actually from our New Jersey Power Products group originally, I worked with him for quite a few years, went to school with him. Not with him, he went to the same university I did, just came back to our site. So we're kind of bringing back some of the Bill and Dave practices to make sure that we're all one company.
That was the management by walking about principle, which became famous in...
Yes.
Yeah.
We're trying to recover some of the good stuff.
Right.
We are the original Hewlett Packard.
Yes, right. Now, let's talk about the spin-offs. When did they happen? How? Why? Obviously, the first... So it was Hewlett Packard until then it changed to Agilent. How did that go down? Was it well received internally? Was it...
It was a very interesting transition. That was the Carly days, some of the darkest days of Hewlett Packard. And I think there was one of the board members was Hewlett's son, Walter Hewlett, I think it was.
Right.
And he was very much afraid that Carly was going to gobble up and destroy everything in her zeal to be ambitious and grow herself.
As in, we're talking about the test and measurement stuff? Right. That would be gobbled up. That would
gobbled up and shut down and turned into a super cash cow, and he didn't want that to happen. So they made a decision to spin us off, the life sciences and the test and measurement, into a solely separate entity so that the computer group could be completely independent. And part of that is also, the stock market wants a clean concept for a company, so they know how to put it in their portfolio the right way.
Yeah, HP was big. It had its tentacles in so many different areas. That would have been a hindrance, right?
Well, the biggest thing really was the market drivers. I was explaining this to Simon, that when you're a portfolio manager, you want to have a certain split of this kind of stock and this kind of stock and this kind of stock. And we represent a problem for those people because we're not a kind of stock. We're a conglomerate. Now, if we're bigger and a true conglomerate like a GE or a Danaher, those companies are not renowned for the products they make. They're renowned for their business management.
Yes.
Okay? And they keep companies as long as they can milk them and make money, but as soon as they're not number one or number two, out they go. So like Danaher just spun off.
The Danaher business system. Yeah,
that's right. And GE business system the same. We didn't want to become that, so they spun us off as a wholly separate entity. And it worked for a while as Agilent, but then it was also a problem when we were a life sciences and a test and measurement company.
Yep.
Which one are you? And it was hurting the test and measurement part quite a bit because every dollar we made, we were becoming a cash cow to fund this growing life sciences business. So they made a decision that that was going to hurt us, and we were actually going to be a liability. So they spun us off again as Keysight, and now we're a pure T&M play. And what we love about it, being part of that test and measurement business, is we're really focused now. We're really 100% of every dollar we make goes back to making us grow.
In the test and measurement space, correct. Nothing else. Nothing else distracts you. HP started out as a test and measurement company. Were they disappointed they didn't get the HP name, or had it been corrupted by the computer?
No,
twice. Everyone was disappointed.
We would have loved to have the Hewlett Packard name.
Yep.
Some of our competitors have said, "Would you trust somebody who's changed their name 3 times in 10 years?" Don't care for that, but it's cost us a negative, if you will, to have to change names and build up that brand reputation again. I think we're at the point now where it's not likely to happen again. We'll grow it back, and we're fine. It's a good name. We don't have any issues with it. It's not something we'd like to have done, but and we certainly wish we kept the Hewlett Packard name because Bill and Dave are still
Yep.
legacy famous everywhere you go. They're
Yep.
known for creating Silicon Valley and spinning off some of the largest companies in the world. I mean, Apple was started by Hewlett Packard.
Yep. So, yeah. Did you know, you wouldn't have known Woz back in the day when he was in the calculator
California.
division. He was,
He wasn't part of my world at all.
Right. So, everyone was disappointed in HP. Did they like the name Agilent? I didn't mind. I thought it was okay. I didn't really have anything
Agilent
against it.
I think the only negative was that right before we spun off, AT&T splintered into many companies, and one of those companies was Lucent. So we became Agilent, and Lucent didn't go well, as you probably
Yep.
know. They got gobbled
Yep.
up eventually by Alcatel and for pennies on the dollar. So this naming thing seemed kind of fake. And I think the
Okay.
Keysight name was viewed much better. And
Right.
It's also,
it was viewed better internally because outside it was a bit of it was like Keysight. It was like designed by committee or something.
no,
I don't know.
It's
It
a tough
was-
thing. Naming is a tough
Yeah,
thing.
yeah.
We don't have the
Yep,
Bill and
totally.
Dave was great. And in fact, Hewlett Packard is a funny story because for years it was Hewlett Packard. You weren't
Yep.
allowed to call it in any advertising HP.
Right.
And
Interesting.
Literally the day that Bill Hewlett passed away,
Yep.
they started calling it HP. Carly wanted to call it HP.
Wow, okay.
He passed away, and
Interesting.
she immediately demanded that everything started becoming HP because it's a message.
No, it's hard. That's why in the industry it's just HP.
Right, but
You know,
they refused. It's my
right.
name on the company. You say the whole thing.
Okay. I can totally understand it.
Yeah.
Why not? You're the one in charge.
Right. I think part of the Keysight name is also the Keysight look. As you see, we're changing all of our products to the black and red, and a lot of that was perceived negatively by the engineers because it's work.
Right.
And it requires us to change everything.
Yeah.
And it's been a challenge to get the user interface, the look and feel right. And the black on black has been a challenge. It's getting better. I think the thing that people are starting to see, though, is it makes us us. It's
Right.
becoming our identity. It's a fresh new start. And
Got it.
I think that's starting to become perceived more positively. It's taking time. It costs
Yep.
money. And one of the things that does take your eye off the ball, you're busy focusing on the way things look as in colors as opposed to how good is the product. So there is a cost to it, but I think it's going to be a transitory cost.
Do you, when you're making a huge transition like that, did the black look and feel come after?
After.
It came after, right?
We spun off, and then about a year
right.
and a half later, we started doing
I
the
thought
black
so.
line.
Why did you think that you needed a new look and feel?
Well, we wanted to be ourselves. We wanted
Right.
to be our own company.
Okay.
We weren't everybody else has copied us, and there's all
Right.
these other products have that beige look. We invented
Yep.
that, and we're ready to be the new Keysight, and that's just really kind of staking
Interesting.
our own turf. And
Yep.
like I said, it's taken a while, but it's
Okay.
really starting to have a positive impact.
Do you do something like that internally, or do you just hire consulting, like a brand consulting companies to help out or to do it?
It was
or
done
what?
internally, and
okay.
in fact, there was something that Ron really wanted to do. The
Ron?
staff, Ron Nersessian here,
Oh, right, yep.
and his staff, they really felt it was important for us to make our new mark, to send a strong message to the world and to us internally that we are now a pure test and measurement company, and we're our own
Interesting.
selves. We're not part of anything else. We're
Yep.
just ourselves.
Fantastic.
Yes, and it shows in all the decisions. I'm very happy with some of the direction we've shifted to,
Yep.
the renewed focus on a lot of our products, a greater amount of investment, and all that money we're not giving to life sciences is going back into the company.
So how is Keysight doing financially? So I haven't looked.
We've
Are
had
they still like a very profitable?
The challenge has been transitioning from a cash cow, which generates great profit, to a profit and growth play.
Got
Okay,
it.
so now we're really starting to grow. We're making our numbers every quarter for 6 straight quarters.
Nice.
Our stock is up nicely, and
Yep.
that's really what we want. There's no question about it, and we have a lot more to go.
Excellent.
Yes.
Is there any pressure from being a publicly listed company to kill off things that aren't very profitable, or can you get by with things that aren't like products you really like but they're not really profitable, or is every successful?
The stock market doesn't look that closely under the hood.
Okay,
They look at the
right.
aggregate total.
Yep.
And they expect you to understand, to make the moves you have to make the
To
numbers work.
do that.
And we are very ruthless about that. If we do things that aren't making sense, we don't
Yep.
want them in our portfolio. It makes our numbers look bad, and our results
Right.
look bad, and we're not generating funding for new things. We don't want to keep it in there. We don't need the market to tell us that.
So you started out as a technical guy.
Absolutely.
Do you still get your hands dirty, or?
One of the things I tell people is I like to keep my feet on the street. So
Yep.
like that 34-460 front panel, I designed that.
Oh, you designed that.
I designed that front panel.
Simon, give us the meter. There we go.
It was an interesting story because we had a lot of price pressure on that to replace the 34401, which was the most successful product in Hewlett Packard test and measurement history. Okay.
It was the most successful
We
product.
sold more logos
Yep.
on that 34401. It was by far and away, at its peak, we sold over 25,000 a year.
25, and how long ago? It was on the market for 20
Over
plus
20 years. I think 84 or 85.
Wow.
A long time.
Wow. So you actually designed.
I designed
Yes.
the electronics for the front
Yep.
panel. Yep,
Fantastic. Oh, you actually designed the electronics
that's correct.
for the front. Wow. There you go. You're the manager. How high are you up the arc? You're pretty
Well,
high up.
I'm the second highest level of individual. Because I
Yeah.
don't have direct reports. I'm a strong influencer of a lot of different organizations.
Yep.
But what this team needed was, they needed a product that was modern enough to really replace the 34401. And
Yep.
they didn't know how to meet the cost. They didn't know how to add the functionality. And I got together with them and we came up with a super simple, clean design.
Yep.
One of the benefits coming from the power products side was power products are the most attacked from underneath of all of our product lines. So we were always
interesting.
more sensitive
Yep.
to cost and more aware of how to get low cost than probably all the other product classes.
Mm-hmm.
And this team, when they developed the 34401, they did the most amazing job. I mean, I look at that design, it's just one of the most elegant, simple, clean, just enough to get the job done.
Right.
And when we went to do this, they were struggling to figure out how to get that same elegance.
Yep.
And my job was to come in and help them achieve that. Now, they had to do the same thing on the voltmeter technology inside. I did not get directly involved in that.
Right.
And they did an amazing job on that. I mean, this voltmeter is simple and as clean as the 34401 was in its day, but the combination of the two, they've now taken this technology and brought it into all of our other products.
Yep.
Okay? And that's really what's made a difference now is, when I say efficiency, it's efficiency in the development cost of the products to get as much shared reuse across all those different products. And also because when our customers use this, the expectation is they're going to use that. It works the same, it's easy to use, they already know how it works.
Yep.
And that's another efficiency because what we had in the past was each group would develop their own web browser interface, their own file manager interface, their own firmware update method, and our customers just go
It's
crazy.
nasty. Yeah.
Well, it's also
Nuts.
hard for us to keep the quality of that very high. We're testing 3 times or
Got
5
it.
times as many things. So
Yeah.
my job is to shut down the multiple different ways of doing things and make it one way that's the best way.
Yep.
Okay.
So you designed the front panel electronics. You laid out the board. Mm-hmm. Wow. I'm stunned.
I like to
Thank
keep
you
them-
very much.
Oh, you like- I guess you
I'm
like this one.
impressed.
Oh.
I'm impressed.
Good.
Yeah, that's somebody that high up would, did you, like, obviously people, you had no shortage of people who could have done that. But did you go,
Surprisingly enough, the reason I got involved in it was because they didn't know how to meet the cost goals we had to hit. So they could do that. This front panel, the assembly cost about $65. The board and the loading of the board, and the design they came up with was about $59. But instead of being an LCD, it was a vacuum fluorescent. They said you can't put out a product in 2010 without a color LCD.
Yeah.
And we worked very hard, and some of the team did a lot of work to find a vendor that made a high quality display that was low cost, and we came up with an integrated design. We actually had to work with our internal people to use a lower cost processor and reduce parts count, and that's something I have a lot of familiarity with.
got it. So you thought you could do the job really well and you went in there and did it?
We did it, and what's fun about it now is they now are much more dangerous about doing low cost and minimal design than they were in the past. So that's continued through a lot of the other products. Because I only have to do it once and show them the way, and then they can follow it from there.
Yep.
And the funny thing was when the original 34401 was done, those guys were aces at it. They were amazing at it. But what happened was we moved all our manufacturing to Penang.
Yep.
And it's much more difficult for people to get on planes and fly, 30 hours to get to Penang. I was already doing that quite a bit. I worked with the Penang team to do the low-cost products, so I had a lot of that knowledge, and I was still going over there, and I brought a lot of that to them and helped share that. We've taken this design now and propagated it through our Japanese organization, which I'm visiting later this week. Our Penang organization does it a lot, and we're looking at other products we can implement it in, these lower-cost methodologies.
Fantastic. So when was this originally, when did you start working on this?
I guess about 8-10 years ago.
Oh, that long. And when did it come out?
6-8 years ago. I don't know the exact dates.
Right. So what is the development cycle? Well, for this, because this was a completely new product from the ground up, basically, wasn't it? Almost. You used some of the old sampling architecture, I think.
Yes, it's multi-slope,
Right.
but it's
Yep.
not using an ASIC. The original 34401 used an ASIC, and ASIC costs have skyrocketed. And you can now do more with off-the-shelf than you could. The quality of the components and the switches and things like that, you don't have to get an ASIC to performance anymore. So this is done with discrete off-the-shelf parts. And no, there's a custom FPGA inside, but that's about it.
This was one question on the forum. Somebody asked FPGA versus ASIC these days. I mean, HP did a lot of ASICs.
We had our own internal IC. We still do have our own internal IC facilities, but as the nanometers have shrunk, the mask set costs have risen dramatically.
Got it.
Okay, and where we used to do analog in analog ASICs to get matching of resistors and things like that, today you can buy that.
Right, yeah, you can buy an off-the-shelf 0.01% resistor and whatnot.
And switches, the leakages and things like that, and the resistance of the switches is much better, whereas before you had to do an ASIC to get that level of performance.
Got it. So is there any, well, apart from the scopes which have the megazoom,
now see, in their case,
ASIC?
they had to develop their custom ASICs. They have a custom A to D and a custom digital ASIC that takes the data real time at gigahertz sample rates and actually builds the entire display in the ASIC.
Yes.
And then they pipe that right out to the display to give you that super fast.
Because you have to get that performance, that instant response performance thing. But on instruments like the ones you work on, because you're not in the oscilloscope division, you're in the, what do you cover?
We're part of EISG, which is Electronic Instruments and Systems Group, is voltmeters, counters, function generators, data acquisition supplies, SMUs, so our Hachiochi team, board test, anything that's not RF or super high speed.
And the company deliberately differentiates scopes because they're essentially they're RF type, they're high speed.
Super high speed.
High speed
right.
RF
and also,
type stuff.
Most of the scopes are kind of divided into two halves. We have our high performance group and we have our high volume group.
Got it.
Okay, and the high performance group is chasing the 60 gigahertz plus to test the latest PCI Express dot whatever it is. In the super fast DDR memories. That's price is secondary to performance in those guys. The high volume scope guys price is everything. They are as good as or better than anybody in the company hitting price points. They're amazing. I work closely with them to understand the tricks they've learned so I can pick them up and bring them into these guys. So
mostly you'd be targeting FPGAs these days because they're still not cheap in volume, are they? For a decent size one, they're not.
So what's happened is they shrink the process geometry of an FPGA. You get more for the same amount of money. But the price doesn't drop. You get more and more transistors. And one of the interesting technological challenges with FPGAs is figuring out how to take advantage of all those transistors. And that means we have to move more and more of the functionality of the product into the digital domain. Now the good news is that's the general trend. So in power products, for example, where we used to do all analog feedback, we're moving almost all our new designs are doing digital. Almost
all digital.
Right, and we're doing that in FPGAs today, but there's a new technology, not new per se, but the one that's coming on very strong, and that is, TI and other companies are coming out with better and better DSP technology. And they're competing with the low end of the FPGA market. In fact, a lot of our FPGAs, we build microprocessors inside the FPGA and soft to get state machines and things like that. So the challenge is, what can you do with all those gates and all those multipliers and accumulators and stuff to get more and more functionality? So
you're from a power background.
That's where I started,
You started in the power group. What are the... do you prefer the analog stuff, or do you think that, or do you see advantages in the new DSP digital approach to power supply digital power supplies? Is the performance, the response is better, the stability is better in digital?
Well, digital, when people first started to do digital, they basically implemented analog circuits in digital. So they took an op-amp integrator and they implemented it in an accumulator in a digital domain. It's way more expensive to do that. But now we're doing things like dynamic compensation that changes with operating point. We do a lot of switching power supply design. We make the switching power supplies that people think are linear supplies. They have low noise and they're super fast transient response. And we can do things in digital that we couldn't do in analog. And we can do it more precisely. And we can simulate a lot of this stuff. In the analog domain, it was much more difficult to simulate, to get accurate characteristics of transistors. We now can correct for anomalies that we couldn't correct for before and get higher performance, more efficiency, and there's no end to what we can do with it. I mean, it's really the sky's the limit.
Because in the the real high performance inverters, industrial inverters and things like that, they digitally characterize individual transistors, and you can get the most efficiency out of. Are you guys doing stuff like that?
Yeah, we just came out with a very high voltage, very high power supply to serve the automotive electric vehicle market. And we're doing fully bidirectional power transfer in that. And we're mapping into the line.
Yeah.
We're dumping power back in the line when you're sucking
Right.
energy out of it, and we're putting power back in off the line with 100% power factor, all done digitally.
That's
And
brilliant.
we can get higher and higher levels of efficiency because, frankly, when
Yeah.
you're talking about 100,000 watts,
Yeah,
people
yeah.
don't care for that heat in the room.
No, every 0.1% of efficiency matters at that.
Well, the bigger problem is when
Level.
they're testing these things in production, they would have to put liquid cooling towers in to take the heat out of the room because it would get to 120 Fahrenheit.
Wow.
So by putting the energy back on the line,
Yep.
they can dramatically simplify the manufacturing process.
Fantastic.
And factories don't care so much about efficiency. They're not in terms of how much power costs are,
Yep.
but they do care about heat and
Yes.
HVAC and noise and just the mess that comes from it. So that's. But the thing I was getting back to your original question, the digital domain allows us to do things we couldn't do in analog easily. That wasn't predictable.
Like?
Like accurate nonlinear feedback.
Yep.
Okay. To do nonlinear feedback in the analog domain involved diodes and Zeners and things. and
nasty stuff.
nasty stuff, and it
yeah.
wasn't, it drifted
Yeah,
and it
no,
didn't work
it's-
precisely. With
yep.
digital, you have 16-bit accuracy at very high bandwidth, and it's very, very predictable and modelable. So
Alright.
it's much, much better. It's just we're learning how to develop the tools and the simulation technologies. The simulation technologies take a lot of computer horsepower. So we're constantly buying new servers, new tools, faster tools. You can actually even ship the stuff off to people like Amazon and Google and use their server farms to
of
do
course.
simulations. We're starting to do that, but it's getting our minds wrapped around it so everybody's adept. I can't tell you how often I take a guy out of school who knows the analog, because you have to start there, and I say, but you're never going to use this. You're going to have to understand it, but you're going to do it all in digital domain. And You have
Yeah.
to become an expert on FPGAs, and they go, oh, they're kind
right.
of shocked. That they
Wow.
don't. I see. All of our
I thought it'd be
engineers-
the opposite. I thought they'd be churning out the digital gurus and nobody knows analog anymore.
Nobody. Well, the point is, we try to hire analog people. We try to find
okay.
those
Right.
rarest hen's teeth people, because you need to have that core
You do.
understanding before you
Right.
go to the digital. You just can't send a digital jockey at the thing and expect them to come up with a good result. They have to have that
Interesting.
that detail. You have to know
Yep.
loop gain and all those things.
Yeah,
It still matters.
Yeah. It's done in the software domain and
That's correct.
compensated for in that case. But you
Right.
still have to understand the principles of how it all
Right.
works and whatnot.
And we're not the only ones. I mean, obviously our competitors are doing
Yeah.
it as well. And what's also interesting is you can provide some of that to the customer. You can provide the adaptability that digital brings to bear in a soft fashion to the customer, so they can trade off stability versus dynamics.
Yep.
And some of our competitors offer that as well. And it's really allowing you to get more out of what you already have.
Fantastic.
Optimize it, yeah.
Design tools. How have they changed over the years? From like 78 when you started, were you still doing the tape on the film,
Yeah, we were using Rubylith
Yep.
and board layout that way, and then it transitioned.
doing it by hand?
Doing it by hand with
Yep.
Rubylith and the
Yep.
little coupons you put down.
Yes, for the IC, for the
Yep.
dip packages and stuff.
Yep, and now it's all
Yep.
on a computer, and it does all design rule checking. You put in all your constraints, all your safety spacings, all your transmission lines, all your ampacities for all your tracks, and it checks everything.
What have been the major advances in the development tool? There'd be one where you switch from the tape to a PC for laid out boards, and then
So it happened in multiple steps. It
Yep.
went from the Rubylith to where the one tool we had was you would draw everything in pencil and then use a giant digitizer
right.
to enter it. You'd still
Yep.
draw it in with pencil, but then you digitize it into the computer. I don't.
Digitize it instead of why? Because that was more efficient at the time.
They didn't
than-
have the graphics technology in the computers. It
Right,
wasn't
okay.
as far advanced to now where you can use a
Right.
mouse and just
Yeah, yeah,
click
yeah.
And pop tracks in. But one of the things that I still, to this day, I'm still impressed by, you take this tool and you'll have, say, 20 traces that are minimum spaced, down a line, and you have to get a 21st trace through. And you want it to go down the middle.
Yep.
And you take your mouse and you drag it through the middle, and all
And
the
all the
tracks,
others?
they move out of the way.
Yeah.
To this day, I still get goosebumps
Yeah,
watching
it's
it do
magic.
that. It is magic. It still is. Because what that used to take before was you had to
rip
move
them
this.
all up.
Well, you have to move this one, move
Yeah.
this one, move this one, and then you'd have enough space and run it through. And then, I have to run a 20-second, and you have to do all over again. It's
Yeah,
just,
yeah.
the auto plow it's called. It's just,
Yeah.
it's still
Magic.
scary cool.
What tools are you using internally to develop products like this? What
So-
PCB tools? What simulation tools? What?
So that was actually PC tools. One of the things that was interesting is we had different people in the company 10 years ago using different tools. About 80% of the company was using a tool called Design Architect, was from Mentor product.
Oh, okay. Yeah.
And that was a good tool, but it didn't serve everybody's needs the best. So today we're on their newer updated tool called Expedition
Yep.
and DX Designer, and now we've pretty much gotten everybody 100% onto the same tool. And for someone like me whose job is to move designs from group to group, that's invaluable because I can take a PC design, a circuit design, whatever it is that someone did, and give it to someone else, and it just works. We have a common core database for all our parts throughout the company with all the coupons for all the parts. If anybody sets up a part, anybody else can just grab that part and drop it onto a board.
Got it.
And the layout tool actually has the full corporate database right in the schematic capture. So you can just
nice.
say, I need a resistor 0.1%, 5 ppm. It says, well, here's the 8 different parts, different power levels, and you just grab it and drop it into your design.
Yep.
So it's our corporate tool group is really, really amazing people.
And that's all part of your efficiency job title. Efficiency in terms of,
they have
or is that
corporate
a
people.
production?
No, we have a
you've
group.
got-
I'm not directly involved in that. I
Right.
take no credit for the things they've done.
Okay.
They've done that without any
Yep.
of my help. They've just done an amazing job. It's really one of the enablers for us to get more efficiency, though. I appreciate the fact that it's there. My job was to demand that we all use the same tool
Yep.
and get on board. And if there's
Right.
a problem with you getting on board, I would help arrange training and help people convert over to it, their designs, because trying to move, we have some older designs that I'm trying to leverage into new stuff, and if it's in the old tool, we have to do what we call a Gerber copy, where they put the Gerbers for the board layout and then trace all the new traces.
Oh, no, yeah. No, that's, yep.
Not fun.
But you have to do that.
Once.
Sometimes.
Hopefully only
Oh,
once.
right, okay.
Simulation is still not common in terms of
Okay.
a standard tool. We have different people like
Really?
different simulation tools. We obviously sell.
So you leave it up to the individual designer to use
Well,
their tool of choice, or?
Depends on what work you're doing. We make we make the premier RF design tool in eSoft that all the RF guys use, and
Yep.
it's used universally by all those folks. You couldn't really do their job without it because it includes the board layout. They use a different board layout package for them because it
yeah, of
includes
course.
the characteristics of the RF or the board's part of the circuit. And then the rest of the people use things like Cadence, Allegro.
Yep.
Is used. A lot of people, frankly, use Tina and LT Spice for simple stuff because
yep.
it's free and it's tied into the parts quickly. So
Right.
you're just trying to do a simple like filter or something like that. They'll just use that.
Yep.
One of the things that our power group is actually really focused on is a tool called Saber by Synopsys. It's a
Right.
very, very powerful mixed signal simulator that can do the digital feedback and the analog interactive.
Wow, that's powerful.
And it's a very expensive tool compared to
Yep.
some of our other simulators, and it's more complicated to learn how to use. But when you're starting to do some of this mixed signal stuff, you really can't do it
It's
without
essential. We can't do it.
Right.
It would be impossible, or it would just be so laborious that.
We've done it without it, but it's much more difficult.
Right.
And there's a couple others. Simplest, I think, is one of the other big competitors for that. And of
Yep.
course, MATLAB and Simulink. We do some stuff in MATLAB and Simulink as well. A lot of people use that, but for Saber, it can actually do the SPICE kind of things with digital feedback. All
Oh,
interactive.
wow,
Right.
jeez, that's. How would you even begin to program something like that? I don't know.
Yeah, and
That's crazy.
it's about 20K a seat.
Right.
Per
Okay.
year.
Wow.
Right?
Okay.
And the good news is because we have people all around
Yep.
the world, one seat serves multiple places.
Oh, it does. Okay, right. So as long as they don't use it at the same time, you're
That's
good.
right.
You can
Yeah,
transfer the license.
we have a big operation in Penang,
Yeah.
and Penang is 12 hours different from the U.S.
Yep.
So, or depending on if you're Colorado, it's I guess 10 hours, but it works out perfect that we can buy one license and get 2 groups to use
Yep.
it.
How difficult is that time gap? Are you always flying there? Do you have?
I go about
do the
3-4 times
designers-
a year,
Yep.
and I spend, I'd say, 4 nights a week on teleconferences at 9
Oh,
o'clock.
4
at night.
nights. 4 nights a week.
Yeah.
I'm
But I get to
Wow.
get up late, so I don't have to get up early.
Right.
But we try to minimize the number of people who have to do that.
Yep.
Because it is disruptive. Not everybody
Yeah,
likes
no,
it.
totally.
I enjoy it. I do a lot of trips over there, and I run a couple projects over there for the low-cost power products. I enjoy it very much. The great group of people, and I think for the longest time they were kind of treated like a little bit less. And
Got
I
it.
don't think they ever deserved that. But
Yep.
that was our manufacturing.
Yeah,
is
it's
the-
like it's the dirty part of engineering.
And the fact is, they're critical for us to be effective is to meet
Yeah.
our cost goals against some of these new competitors coming in. They're as strategically important as any part of our company. So you mentioned tools before. We really didn't touch upon firmware and software tools. And one of the things that the company is really focusing on right now is standardizing on our software infrastructure
Right.
and our firmware infrastructure. So we've been a Windows CE house for many years.
I was going to
And-
ask about CE.
Microsoft
Yep.
is sunsetting Windows CE.
Ah, right.
And I never heard of this before, but evidently Microsoft will not let us buy a bunch of licenses and keep shipping after the deadline. They will not let us ship the product after.
Wow, they will stop you from. They'll sue your ass.
We
if
can't
you-
ship any product with
Wow.
Windows CE 6 after 2021. And we can't ship anything with Windows CE 7 after
Doesn't
20.
this have Windows CE?
Correct.
Whoa, what are you going to do?
I can't tell you what I'm doing.
Okay, but
trust us that we're going to take care of it. Well, one thing is we can switch to Windows CE 7, which is very similar to 6.
Oh, okay.
And we're looking at...
oh, sorry. So it's just they're not discontinuing CE. It's a version difference.
Right. Now, when they came out with Windows CE, what's 8, it's not called 8. I think it's called something else. But it's different enough that we're not probably going to continue with that. We're going to do something different.
You'll have to... You think it's worthwhile to switch?
Yes. Well, Microsoft does certain things really, really well.
Yep.
So, for example, they know how to make a thumb drive driver, so it works with every thumb drive. They know how to do LAN, so it works really well.
Yep.
But for us, what we found is that they're very inscrutable to get performance out of it. It's very large and bloated, and we don't have enough control. So we're looking at alternatives that are more effective. Also, the processors today, when you buy them, don't come with Windows CE support. So that costs us a very pretty penny to have support for Windows CE developed for these processors.
Oh, you have to get them developed if you want to use a...
So, like, for example, when you buy Windows CE support for a lot of the low-end embedded processors, it's mainly because we paid people like Adneo and others to do it, and then they get to sell it to other people.
Ah, got it.
We paid all the cost.
Wow, and they get the benefit.
Not
interesting. Wow.
Whereas today, if you get a processor, they all come with Linux support, for example.
Got it.
So Linux is one of the things that we're looking at very seriously. There's a couple of other RTOSs that we're looking at for low-end products, but CE is, we're looking at sunsetting that. It's been a struggle all throughout. Like I said, there's been some good things and some not so good things. One of the things that we get a lot of negative feedback on is boot time.
Yes, it's important. Yeah.
People accept it, but they don't like it.
Yep.
And that's something CE has been very difficult to get good boot times.
It's a differentiator. When I'm reviewing a product, if I'm reviewing a new scope and it boots up in 5 seconds, that's a wow factor.
Yeah.
Right.
Well, it's also the analog. That's what you had.
Exactly. On, off, and boom. It's good to go.
Yep.
Okay. So you are focusing. There is some focus on that.
There's absolutely some focus on that. In fact, this team, when they developed this product, they took 2 of our best firmware guys and they went off in a corner for 3 months and they did a lot to optimize it because it was over a minute when it was first developed.
Well, yes, I remember. I got one of the early ones, I think, firmware releases, and you halved it or something. Yeah.
That took 2 of our top firmware people like 3 months to do that.
Wow, really?
It's not easy. And they could have done more, but it would have required an even more invasive change to the code, which would have raised a lot of risk. You can do what's called a hibernate mode, and you basically take where the thing was at when you turn it off, copy it, and then reboot it like a laptop does. But Microsoft doesn't make it easy.
Interesting. With Linux, do you use an industry build, or do you find that you just have to maintain your own branch of it or something like that, so to speak?
So since we don't have any products out yet, I can't go into a lot of detail on that.
But if you had to, if you did end up
you want somebody who's going to be able to support that product and make sure that they take care of their part. And also there's some issues with licensing that you really need them to do that. Linux has got some strange copy issues that we have to be very careful about.
Right. Interesting.
Because open source code can be terrifying. You may have to publish all your code.
Yeah.
Your internal code, including your code.
Including the product code. Every line of the product code.
We're not doing that, obviously.
Right. Okay.
But there have been some very famous situations. One of the most famous was Linksys made a router.
Yes,
WRT54G. And they used open source Linux, and they didn't realize that they had to publish it after it came out, and then they were forced to release all their internal code, and several people have made pretty good money coming up with modifications to their code, like Open WRT and things like that.
Yeah, that's right. It runs on that particular unit.
Right, and then it got so popular that they figured out, well, we'll make a WRT54L, which had Linux in it, so they could do that.
Right.
And then they turned this a bad situation into a good situation.
An actual product. Yeah.
Right. So Linux has got a lot of challenges with it that way. There are ways through the forest, so to speak. It's got its own headaches. I mean, I don't think we're going to see quite the solidity of LAN and USB that Microsoft, they do more LAN and USB than anybody in the world.
Right.
Okay, because the PC is so many out there. It's going to be a challenge to go into new code space. There's things that were great, and we're going to have to make them better in this new solution, but there's other things that we're going to get when we change.
One of the questions on the forum, a very good one. Back in the old days, when we were boys, you used to get schematics in manuals. When did that trend happen in, and why?
Well, the biggest reason it happened was because products weren't repairable at the component level by most people. When we went from through-hole to surface mount was the first thing.
Right.
That's when it started to change. But the other place it started to change when we realized people were copying our products.
Okay. Right.
And literally, you could go in and down to the component level troubleshoot. And we spent a lot of time and a lot of money creating very complex troubleshooting trees. We used to do things like signature analysis for the digital ICs, and you could repair a product with down to the part level. Today, with bulk grid arrays and fine pitch surface mount and RoHS compatible solders, it's and QFNs and things like that, the DFNs, I should say, where the leads are underneath the part. It's very difficult unless you have exotic repair equipment to repair parts. And we don't want to have to sell the parts. You can't buy some of these parts in low volume in less than 20 weeks.
But there's no obligation to sell the parts if you publish a schematic, is there?
Well, for our customers, if we say it's supportable down to the component level, yes, we have to help them repair it.
But why can't you just go, well, look, here's a schematic, but it's as is? Or here's a part of a schematic, it's as is. No support intended. Is that a legal thing? Or?
No, it's not a legal thing. It's a matter of creating something we think is good for our customers.
Okay.
And we think just throwing those stuff out there hurts our business, it hurts our customers because they're not getting enough guidance to be able to repair the product correctly.
Got it. Right, so you think it could reflect on your reputation if you gave them the schematic and then hands off?
Keep in mind, we have to support the product everywhere in the world. We have support in just about every country in the world. We are the most supported products in test and measurement around the world. Now we have to create those service manuals. We used to translate them into multiple languages.
Yeah.
Okay, we had to support them. So when someone had a question about the schematic, we had to answer the phone. And those costs took away from creating great products.
Got it.
And so few people today, the reliability of our products is much higher today than it was 20, 30 years ago. Yeah. They don't fail as often, and when they do fail, they don't have the facilities to repair them. It's just much more difficult. So we don't even repair our products when they come back. In many cases, we swap out.
It'd be a board swap kind of thing.
It's something everybody's changed, but a lot of people complain about it because they want to repair it themselves, and then I don't think they realize how much more difficult that actually is to do than they think.
Yeah.
And for the small signal analog, if you're a trained analog engineer, I've repaired stuff without schematics. You just look inside.
Yeah, of course, and you follow it around.
And you've
sniff
done that,
around.
sure.
Yep.
And you can,
follow your nose.
or even shotgun a few parts, you can fix it. But some of the parts, they're very specific, selected for us, and we would have to sell them for you to repair it if you wanted those parts. And that's very expensive to do and maintain for the huge volume of products that we make.
What about just like theory of operation, block diagrams?
That's gone the way of the...
You do? You still providing some of that?
Product to product, we do provide some theory of operation. Okay. Where we feel it benefits us in terms of creating a brand benefit, where we think explaining how we do things differently and it's good, it helps. But we're not there to help them. We do get requests, for example, from a lot of our military customers, demand that we provide support for repair.
Interesting.
Because they don't want the thing to leave their facility. And we try to work with those people specifically, and we will actually provide internal documentation to key customers who make those kind of demands, and we feel it's the right thing to do. But for general, we don't do it.
How do you feel about the clones of your products? I mean, if you look at this, there's almost an exact clone from Seal, like the user interface.
Yes.
Like not so much the performance of it, but they try and match, but the user interface is almost identical.
Yes.
What do you guys think about that? Do you just laugh and go,
No, we don't laugh. We're very upset. Because we spent a lot of money and time to create this thing. A lot of the money and time today is in the user interface because it's one of the differentiators. And when someone copies it, they're stealing.
Right.
Okay?
Yep.
And what we've learned, it's taken us a while to figure this out, but I mentioned this to Simon today at breakfast. There are legal ways for us to protect ourselves. There's what's called a design patent.
Yep.
And we're starting to use them more.
You are?
Yes.
A lot of people will be going, design patents.
Design patents protect the way the front panel works, the way the product looks and feels.
Yep.
And they're actually created in China where a lot of the copying is going on, and they're very easy to prosecute.
Right.
Okay.
They're easy to prosecute in China?
In China, yes.
Really? I thought it was the opposite.
No, China has recognized that in order to become a world-class economy, they've got to protect this.
Interesting.
We do copyright patents. We have for a long time.
But you haven't done really design patents, so when you did this, you didn't...
We didn't do a design patent on this. We didn't figure out that design patents were a valid thing to do until about 4 years ago.
Interesting, okay. So it's a modern phenomenon, really.
Well,
or you just didn't...
Our legal department didn't want to do them because it wasn't effective until China passed a new design patent law that they're now enforcing.
Right.
And it's much less expensive to get a design patent than a regular patent, both the cost of creating it and the cost of submitting it.
Really? It's significantly different?
Well, for a regular patent, you have to write a complete treatise on how the thing works.
Right.
Enough so someone else can easily copy it.
Yep.
And one of the challenges with what do you call the other type of patent that you're more familiar with is that you're providing a primer for people to
Yes.
copy your design. And so therefore, one of the other challenges with a regular patent is what's called observability. If you can't observe and know for sure that they use that, you can't patent it. Because all you're doing is teaching them how to copy you, and you can't stop them because you can't prove it. You can't say, I think you're stealing my thing, but I can't prove it. So we do patents where it's fundamental to the feature of the product, but in many cases we don't. So for example, our new true form function generators use some proprietary technology. We could not patent that because we would have shown you how to do it.
Got it.
All right?
So you decided to keep it internal.
It's effectively like a trade secret.
Yeah.
Okay?
Yeah.
But design,
Which is the opposite of a patent. You either patent it or you trade secret it.
Well,
Or you open it.
there's actually a few other things out there as
Yeah.
tools for us, but the trade secret technically is supposed to be kept hidden even from people inside your company.
Oh, okay. Interesting.
It's like the formula for Coca-Cola. It has to be
Right.
kept, it has to be limited in who can get access to it.
Okay. Is this
Qualifies
for
it.
a legal reason or just
Yes.
because? Oh, interesting.
Otherwise, it's common knowledge throughout your company how to do it. Then someone could leave.
And somebody leaves and takes it with you, and legally that's okay.
That's okay. Yeah.
Wow, okay. But legally, if you limited it within a certain team and that person never worked in that team and they went somewhere else and somehow they got that knowledge, that's deemed to be stealing?
No,
Would
if
that
they
be?
figured out another way, they
they-
can use it. Yeah.
Right.
And eventually, all trade secrets. Eventually, everybody knows what Coke's made out of now. They hook up one of these pieces of what used to be Agilent. You can figure out it's got cloves and cinnamon and sugar and all those things. You know, it's not that hard to copy anymore.
Right.
That's the nature of trade secrets. They slowly leak out.
Yeah.
But all we're looking for is to keep people from rapidly copying our products.
Mm-hmm.
You know, a year after we come out with a product, they've got an identical one, and of course our customers think we OEM'd it from them, which is the most insulting part of it. Really, it's the exact opposite. They're stealing from us, and they think we're cheating and copying, from them, which is not what we want to have happen.
But I have to ask about the Rigol thing. You guys were Rigol were the OEM for
They were the ODM.
scopes. Original design manufacturer.
Right.
But you guys helped them technically. I heard, so the rumor goes.
Yes, absolutely.
And in terms of design and manufacturing, you helped them. And do you feel like you've created a monster or a monster competitor?
Well,
or what?
I can only say that relationship is no longer.
It's no longer existent.
Right.
Okay.
That's all I can say about it.
Okay. So do you?
I think in retrospect, we all agree that we shouldn't have done what we did, and
Right.
we've made other plans since then to do things in a different way, a better way, and we're trying a different model to work with ODMs that's more effective.
Right. So you do work with ODMs still?
Absolutely,
And
sure.
so what products? And can you?
I'm
Off
not
the top.
obliged to.
Not
to go
obliged to say, but
Yes.
some of them may not be.
Well,
Keysight
we work with
designed.
ODMs because it's
Yeah.
a way for us to get more products out in less
Of
time.
course, yeah.
And in some cases, they may have unique manufacturing technology,
Right.
for example, for ultra low cost,
Mm-hmm.
and it allows us to expand our scope and get into more markets more quickly. And that's something that's sometimes more important than doing it ourselves.
Of course. Would you look at buying those companies? I don't. Do you guys buy many
we have.
companies these days?
We are growing our acquisition
Yep.
process.
Right.
I was telling Simon this morning, we used to have rules when we were part of Agilent that we wouldn't buy anything smaller than a $500 million.
Interesting.
was a
So there was a
certain-
monetary figure.
And the reason
limit.
that was because the cost of integrating the company in is
Was too
fixed.
much.
Well, it doesn't matter if it's big or small. You still have to take whatever system they have and convert it to your system. So it costs almost as much to take a small company and bring it in as it does a big company.
Right.
And then when we realized that what that was doing, and our competitors were not following this plan, they were buying smaller companies. We started to put much more demands on our acquisition team to be more effective at integrating into these companies, so
Got
that
it.
move that line down. Because in some cases, small companies have incredible technology, and you don't want to OEM it from them. You want to own them and keep it for yourself.
Yep.
So we've purchased, Ixia, which is a big company. We bought Signadyne, small company, and where they have a key technology, we need to be successful quickly. It's a great way to get going, but it puts pressure on your acquisition team to integrate their HR, the finance model, their benefits packages. In the case of Ixia, we bought Ixia, and we're rapidly moving people from facility to facility to cut our overhead costs
Right.
without disrupting their development process. And that's something that we're very proud that transition is going much faster than it would have when we were part of Agilent, for example. Agilent, they said it would take a year, it took 2. Something like Ixia, I think they said it would take a year, and now it's taking 9 months.
Okay, so you're moving towards a position where you can more cheaper and more readily acquire companies that have cool tech, which you guys are
And smaller
interested
size.
in, and smaller size.
Well, now we're a pure T&M play, and with
Yep.
T&M, someone develops a new technology, you got to pay attention to that. You
Yep.
got to be able to bring it into the fold. And in some cases, it's a big company like Ixia, who is the world leader in network security, and all of our products have LAN in them. And you heard about the shutdown in the U.S. where someone took over all the webcams.
Yes, yeah, the webcams, yeah.
We can't tell our customers we didn't take care of that. So Ixia is a big part of our strategy to have the world's best internet security in all of our products and sell internet security technology.
That's
as well.
interesting, because you don't want your multimeter to become machine. For not that there's huge volume in these like there is webcams, but still. Yeah.
Well, but it's also, if you look at the data, the measurement data that's inside these things, they don't want that stuff leaking out.
That's proprietary. That's company proprietary. If I had my multimeter and it was someone was spying inside.
Right, they could tell how many products you manufactured a day, for example, if they could crack that, and they don't want that information getting out. And there's a lot more to it, too. I mean, just going forward, internet security, as the Internet of Things becomes pervasive, is going to be more and more important to test internet security as well. So we're paying attention.
Is there a point to buying a company and leaving them alone?
We've done that as well.
You've done that?
Less commonly, we're looking for a strategic fit that makes sense to make us a stronger overall company.
Got it.
I mean, we're not looking just to bring the cash that they make in. That's not a kind of acquisition we do very often.
Right.
At all, really. We're looking for things that enhance our overall company, that fit with everything else. So leaving them alone, if it's a segment of the market that's really independent, but we need to have access to it, we might do that, but I haven't seen that yet.
Back to the design of these sorts of things, how big's your design team on
It varies
meters?
From something like a meter might be 10 or 12 people.
Right.
3 or 4 analog engineers, one or two mechanical engineers, and 3 or 4 firmware, and maybe a software person.
Oh, firmware and software are different.
Absolutely.
Oh, it's software, like as in PC software you're talking about?
PC software, and then there's this kind of bridge gap where you have the web browser technology, which is sort of a hybrid between the two.
Okay, right. Okay. Interesting.
And software is one of the areas that we're investing in more heavily than any other area. We just started a new center in Atlanta, in Atlanta, Georgia, and we've started a relationship with Georgia Tech, and we're growing a huge software center there to expand our standard software across all of our products. Because software, not everybody wants a front panel, and when you do more sophisticated solution-oriented measurements that have multiple pieces of equipment, the front panel's not enough. So you take a Pixie system, there's no front panels, and you're solving a much larger problem. You need software to make that really fly.
Is every product going towards web browser, like a web page built in, what's the correct term?
LXI requires you to have some sort of a presence on the web.
Right, it does. So, because now you can go in and you can access the web page for the instrument.
Right.
And that's how you can control it at a basic level.
One of the things that I'm working on actively is if you go through all the different products that look the same and you look at their web presence, what they come up with, it varies on product to product. Because this design team thinks this is what the web should look like, and this design team thinks this is what the web should look like, and this design team doesn't have enough money, so they did the minimum necessary, and it's not good for our customers. Okay? We've had cases where we went overboard and spent over $1 million, $2 million on our web interface on one product. And it's amazing, but we could have done it with a software package for a third of the cost.
Got it.
The only reason they like it in the web is that the field engineers don't have to install the software before they demo it for the customers.
Correct. They can just go on their phone and go straight to the web address.
Yeah, that's not a reason to spend $2 million.
Right.
Okay? And the problem is everybody thought the web was going to not have to be updated. The web was always going to stay the same. Well, you can't get Java, can you? You can't get Flash, can you? So it hasn't worked out to be as good, and it's evolving just like every other part of the PC is evolving. So it hasn't been this zero maintenance thing, and we thought it was going to be. So we're pulling the web back to more of a common level that's going to be more standardized across our products and more rapid for us to deploy more easily. Still give you the local control over the web, which people want, but not as full-blown as some products have done, and it's not as stripped down, which is not good enough from some other products. I mean, one product we make, the web control consists of a window you can type Skippy commands. That's not very useful.
Well, it's,
it meets the LXI
hardcore
standard.
Guys cheer, but apart from that.
Well, that's an easy thing to integrate, but that's all the integrated.
Right.
It meets the LXI standard, but that's about it. Most of our products we're trying to standardize on is where you have a view at the front panel and you can press buttons and the display looks just like the front panel.
Exactly.
And that turns out to be, for most people, they just want to remotely control the product and verify that it's doing what they expect it to do.
So that's what they expect. They expect to see something like that.
Well, no, there's a group of people who want it, because the web has a giant CRT, you can do much more than you do on a limited size front panel. And you can even add additional high-level constructs that you wouldn't put in the product because it was hard to use on a small display.
Of course.
That's the area that I think there's more debate. Can we do more of that? And my feeling is, from an efficiency standpoint, let's get everything common. and then let's move the whole thing as a phalanx forward and make it better, more efficiently. Instead, we have some groups going all the way to here, some groups going to here. It just doesn't lend itself toward efficiency. And what really frustrates me is we have a concept, a name that Ron came up with in the management staff called One Keysight. We want our customers to have a consistent One Keysight experience across all of our products. That's as important as any one product.
Got it.
So we're really trying.
We're a bit cynical, us engineers in the market, in that we think that's a bit, that's a bit corporate-y, silly. But if it wasn't there, you'd probably miss it. It's probably underappreciated by us.
I think most people,
engineers.
if you talk to them, if they own an Apple product,
right,
Apple's the master of that one Apple,
right.
if you will, but they have that consistent. Now, that doesn't mean Apple's perfect.
No,
There's lots of areas that there's issues with Apple's implementation, but for the most part, it makes people brand loyal, and they do have a consistency and a quality to the experience that they're very big on. I'm not saying that we're trying to clone Apple, but we are trying to take some of that same shared experience and make it more consistent.
So we'll find this user interface on most of your benchtop products, like this?
We have a box coming your way with the new E36 11, 12, or 13. I don't know which one they're going to send you. And there are screens on that are identical to the screens on this. For things like setting up the LAN, things for setting up the file manager, why have different experience on each one? It's a file manager, And that's something as an example that we literally have 4 or 5 different implementations on this exact screen because it was developed here versus here versus here. That's not acceptable anymore. We're paying for something 3 times.
Oh no, of course,
that's crazy. And our customers hate that. They learn how one works.
I don't. I want to be able to use the same. I expect the same interface.
And you're not getting it today.
Yes, right. But that's being worked on.
Absolutely.
Excellent. How quickly can you spin? Fix firmware issues and things. Someone reports a firmware issue on a product. What's the mechanism to fixing that?
If a firmware issue comes up, the hard part is getting it to the people who can fix it. And because we're a big company, it typically goes into our support group. The first thing they have to go is do it valid, it's truly a mistake. And sometimes that communication takes a while. Because this is not the customer who wants to just sit on the phone on hold waiting for the support person to describe it and document it. That can take the longest amount of time. When it gets to the design team, depending on how hard it is to fix the bug, that can take a couple days, it can take a couple weeks. If it's a case of a memory overflow that only happens on a rare occasion, that's the hardest thing to catch. That might take 2, 3, 4 weeks to get it, catch it with its pants down, so to speak. Once you find it, it takes very little time to fix it, and then it takes typically a week or 2 to guarantee that we didn't break something else. We do exhaustive testing before we ship a firmware update out, because the worst thing you can do is fix it and break something else. Right. So that delays us getting out there because we have very, very thorough regression testing, and even that doesn't have perfect coverage. So we'll pass it around to people to make sure that other people to make sure we didn't break something else in the process.
Is that an automated testing? Do you have automated tools in place to exercise all these functions remotely and just go through every possible?
Well, we do for the buses, all the different buses, GPIB, LAN, USB, but front panel is very difficult to automate. I mean, you can use vision.
Yeah, but you can push the buttons from the...
You can push the buttons, but you actually have to look at the display. You have to look at it, and with vision systems, it's very complex and time-consuming to program vision systems to simulate all that stuff and catch it. And okay, so it's different. And someone still has to look at, how is it different, and figure out what that means. There's no artificial intelligence engine to make all that happen. So front panels are probably the biggest headache when it comes to automated testing and catching things. The bus stuff is much more amenable to automation. And also, though, a voltmeter, you're measuring voltage, we have to make special fixtures that feed different reference signals in of different types. So, and actually the hardest one, believe it or not, to write regression is power products, because you have both sourcing and loading and measurement.
It's nasty.
And different types of sequencing. So for example, most of our power products have the ability to put out sequences. And with different time delays and all that, so that can get very complicated to do regression testing.
The 3458A, there's rumours that maybe a new one's in the works. Are you still going for those sort of, the top of the line Cow Lab type instruments? Is that still on? The
3458 is one of the most revered products in our history. Today, it has not been eclipsed by anybody for absolute performance. We know that's really important, and we will not let our customers down.
Okay.
That's about all I can say. Okay.
Being worked on.
I didn't.
It's being considered.
We will not let our customers down.
We will not let your customers down. Well done. All right. With old products like that, I mean, how long has that one been around?
As long as the 34401. They were released
You're right.
a few years
Okay.
of each other.
Yeah,
like
so
mid-80s.
Yeah,
late
20,
80s.
30 years.
It's been a while.
Wow. Have you lost talent? I mean, clearly you're going to lose talent if people know, like at such high end, there's so much subtle magic in there that.
So I actually managed the two guys working on that.
Yeah.
The first time we tried to do a replacement on it, and it was fascinating for me to learn the kind of subtleties they have to go through on that. And I learned a great deal about high-end voltmeter managing those two guys. Both those two guys are still with the company.
They're still with the company.
Now, the four guys, the four horsemen that developed the original 58, none of those four guys are still with the company. One of those four guys is with one of our biggest competitors that makes DMMs.
Right.
Okay? And he's an amazing engineer that we lost. We were very unhappy that he went to the dark side. And he's still developing with them. He's still doing quite a lot of good things for them. The 58 has some of the most challenging aspects to it, the subtleties of that. One of our R&D managers who was running the group at the time came over, and one of the four guys was still with the company, had a handkerchief laying over the circuit board when he was testing it. He says, "Why are you doing it?" He says, "Because the subtle differences in the air temperature going over some of the parts were moving 10th of a degree, and it showed up as noise. You could see
it.
You could see the fluttering of the air on top of the parts was changing the DC measurements."
Yep. So is that hard to? So you've still got some talent.
Oh yeah. Well, the R&D manager that managed those four guys is still with us, and he's busy and has been busy training a younger guy he's been there 15, 18 years. He developed the 34.
I was going to say, yes, some of them apparently went into this.
Yes, and both of those guys are still with us, and we're looking at how we can take that to the next level, to kind of do it even higher. We have a 7.5 digit model now, and the 7.5 is very close to 58 performance.
Wow.
I mean, in some areas, we know some of the stuff we'd have to do to upgrade it to that next level. So we came very close to having a completely new 58 design, but part of the challenge with our old management team was they said, "You're just replacing the revenue we had before. There's no growth in that. There's no new profit in that." And we were part of the life sciences cash cow. They didn't want to spend that money. No. Now that we're a test and measurement company exclusively, there's a lot more willingness to be having a premier product in our catalog that we understand.
Got it.
And that's one of the great things about being a pure test and measurement play, is we're much more focused on what matters.
The reference inside this and others, are they getting difficult to get?
No.
No?
So that's an interesting story. The reference that's inside the 3458 was developed by us 30 years ago, and we came to the conclusion that we're not the right people to make it. So we gave the design to Linear Technology.
This is the LTZ-1000?
Correct.
Yep.
And
okay, you guys developed
We developed it, and we gave it to them.
Yep.
And we have a big burn-in system in our factory that we mount them in little boards, and we burn them in, and we sell graded versions for better results. Now the 7.5 digit one, this is the 7.5 digit. Uses the LTZ-1000. It's one of the things that allows us to get to 7.5 digits because the drift. This doesn't have all the hooks that a 58 has.
Right.
It doesn't have the level of ACAL. It doesn't have the AC measurement technology that's unique on the 58. Some of that stuff is more straightforward. We had already started to work on redesigning that, and stay tuned.
Okay.
We're in the process of looking how to take things to the next level, because there's still a lot of new measurement technology that can be done. A voltmeter is a fundamental building block for a lot of what we call synthetic measurement technology, and we're looking for how we can grow into other measurements. And that's one of our competitors down in Texas does a great job. All they do is synthetic measurements.
Right.
Because their granularity is a little card about this big. They pop into a frame. We have focused on the standalone. They focused on that. There's a significant opportunity in that area for us, and we think you're going to see more of that over time.
Interesting. What sort of volumes would those high-end instruments sell at? I wouldn't imagine there's how much would they have to sell for to make it worthwhile? All the years and years of developing such a high-end product with such a limited market, which is basically Cal Labs.
It's not as limited as you think.
No?
No, and one of the bigger opportunities for the 58, and it's kind of surprising, when you look at high-volume consumer products, throughput is a huge factor. for these people. Where the voltmeter, even if it's a $10,000 box like the 58, it's the cheapest piece of equipment in the rack. You start putting a spec in or a high-end scope or something like that, it's 30, 40,000, and you've got material handling equipment trying to move this stuff in and test it in a few seconds. You put a 8.5-digit voltmeter in that system, you don't have to change ranges ever, and you still get an accurate reading.
Got it.
On a 6.5,
so it's much faster test throughput.
Much
for the
faster
product.
test. You don't have to change ranges. You can lock it on a 100-volt range, no matter what signal comes in, you get an accurate reading. On a 6.5, you might have to change ranges.
And that takes time.
And it takes time.
And
the
it slows down your product.
That's right. So we have some people using the 58 for its throughput benefits.
Right.
We have other people who build large multi-base systems. They put a 58 at the bottom of the rack, and they recertify and cal everything else in the rack every day.
Right.
Because they want the system to be robust. And we sell into military aerospace. It's a very popular configuration. So it's not all just cal labs. In fact, frankly, cal labs, we've lost a lot of that business to our big competitor in Everett.
Got it.
They've really taken over a lot of the cal. They really focused on cal as a big deal. We get less of that than we used to get for sure. And these other things, this kind of transfer standard where they mount it in the rack, they just calibrate the 58 and then they put it back in the rack and it calibrates everything else.
Got it.
And because it's so accurate, that works. You might have one of these. They might have some Pixie cards, some other things. An ARM, a function generator. The 58 has incredible RMS AC measurements. It can verify all those things in the rack. They just route everything through it. It does a confidence check and a calibration, and it's less expensive. It's smaller than the other competitor's product.
Could we expect to see an 8.5-digit bench one like this rather than a rack meter? Because if there's benefits to throughput, I mean 7.5 digits is almost there. But if you can get the extra,
I don't know exactly what we're going to do that there. That's an interesting question. I don't know if there's as much benefit to having it on a bench where you're dealing with data on the front panel.
Right, it's more automated system rack stuff.
Again, the AC measurement technology in the 58 is something that has a lot of benefit in a standalone like this. So we are looking at how can we bring that kind of technology forward. But the pure 8.5 digitness, there was a lot of debate to do a 7.5 in this format.
Okay,
and
interesting.
We fought that battle over and over, and then finally people said, how much will we get out of it? And they said, the technology is so common, we think we can do it fairly quickly. It's one of the tricks is if you can make the effort low, people stop arguing with you. When the effort's high, like a 58 replacement, they really argue, down to the bone because it's going to cost you $12 million for a project to do it. For this, this was a follow-on to the 60 and 61, and it took a lot less time because they planned for it.
Oh, so when you're first designing this, you thought maybe we might do a 7.5, or did that come later?
They knew the 7.5 was on the roadmap.
Okay.
We knew it was coming. They didn't lay out all at one time, but still because we had the front panel and we had all the other pieces, they could do it with a lot less resources. So instead of having a team of 12, I think it was a team of 4. And the ME did it in 10% of his time because the package was already done.
Exactly. It's just a matter of change. Engineering the 7.5-digit measurement solution, everything else is the same. Yep.
So it was a lot quicker, a lot smaller project team, and as a follow-on, and even all the marketing literature and documentation was reusable. All the screens are the same, for example.
Exactly.
So the firmware was minimal change.
Got it. Do you laugh at the competition that try and do like 6.5 digits and their specs aren't even close, or are some of the Chinese competitors?
We never laugh at anybody.
No. But are some of the Chinese competitors getting there?
I think the biggest mistake we make is to ever underestimate our competitors.
Right.
We were talking about this morning. In the U.S., the Toyota and Honda came into the U.S. market with terrible, terrible, inexpensive cars. So did Hyundai.
Yep. And of course now they produce the most reliable.
And they're the largest selling car in the world. Hyundai is the fastest growing car company in the world. All right, ignoring your competitors, big or small, is always a mistake. Being arrogant was a big mistake we made for many years. And it's something that will not be repeated if a few of us have anything to say about it.
Excellent.
You don't get to be the best and then get arrogant. You won't stay the best for very long. So what we can talk about is one of the things that I really was happy to be able to do this with you is the kind of shift in how people learn about products.
Yep.
And one of the things I tell people, so for example, we developed the 36, 311, 12, and 13. I demanded that all the projects on the project team go to your blog and read about all the things you did on Legal and everybody else.
Yep.
I said
all the criticism, all the vitriol,
but all the things they get right too. I always tell people, I don't want to know what they got wrong. I want to know what they got right. I want to learn what they figured out that I can use.
Yep.
And Steve Jobs said, "Art is steal."
Great. Absolutely.
I look at something, what you provide to the industry is much like a movie critic. You save me from watching bad movies.
Right.
Okay? And at the same time, you teach me what to look for and what the craft of a great movie is. So we really appreciate what you bring to the market, and the fact is you're much more accessible than those millions of customers that you represent. So it's something that, as we've tapped in more to social media, we think that you are really a valuable resource for all of us in the test and measurement industry. You make our industry a better industry for it. You are an objective purveyor of how good products are. I think you're going to make all of our products better. You're going to make their products better,
I hope
and you're
so.
going to make our products
That's the
better.
intention.
Right, and that's something that I think is really exciting and a little scary too, because we don't have any control of what you
Of
say
course,
or
no,
anything.
exactly. It's
And, so from that standpoint, it can be a little frightening. I did not come to this today, without a little trepidation.
No, you've got to take the hits with the,
That's right.
they've got to, if your product fails, like the meter, for example, you remember the
RF susceptibility,
1272
Yes.
meter, and there were soldering issues, and they've gone through. But I like to think that people value the response
That's right.
that you give. If you just ignore it, then they're not going to give out and say, "Hey, yep, we admit it's a problem. We're working on it." Everyone's going to think better of the company.
There's an old cliche that it isn't what you do when you fall down; it's what you do when you get up.
Get up, yeah.
And to us, what you bring to the market is really an invaluable resource that makes us better.
Excellent.
And it's something you can harness that and get a perspective, because when you say what you say, if your readers don't agree with you, we read that too. So we get a weighting, and it really helps us create a perspective that it would be very difficult for us to get any other way.
So you're actively looking to be on the forums and things, and in an official company.
We have
way?
all of our project team members.
Yep.
For the low-cost products, I demand that they read all your forum stuff on all the products that compare to our product. to learn.
Fantastic.
We also buy all of our competitors' products and tear them down.
Yep.
First, we evaluate them in a black box way, and we've instituted a practice where each of the engineers on the project has one of our competitors' products, and they actually have to use it during the project on the bench.
Interesting.
And every few months, we sit down and say,
Wow.
what do you feel now? And then some things that they got really right, and sometimes we try to incorporate them in our product, and other things that they didn't get right, and we try to say, well, how can we do it better? What don't you like about it, and did we end up tripping into that and doing it the same way? No, that's, let's move the bar up. And so I think you've helped make that possible. So to speak.
Fantastic.
So that's how we're going to stay ahead. Well, I think we have some interesting stuff in all the different products. One of the ones I find is the most amazing is what we call TrueForm.
Yep.
Okay, TrueForm is really, and I told you before, it's a trade secret, but there's aspects of it that I can talk around without giving the trade secret. If you look at a traditional DDS style function generator, DDS is great because it's cheap, but it's got all sorts of problems. It's got jitter. It doesn't work well for other types of square waves, for example. Square waves are horrendous with jitter in DDS technology. TrueForm has allowed us to dramatically simplify the structure of a function generator. I don't know if you're aware, but in the older function generators, they would not generate square waves with a DAC.
Right.
They would generate a triangle wave,
Yep.
and they would run that into a comparator.
Oh, it's just no.
And now, you would have a limited, like 2 or 3 different slew rates, and you would have like a 10% minimum duty cycle. Now with TrueForm, you can get less than 1% duty cycle, and you can get infinitely variable slew rates. And that makes the product so much more usable on your bench.
Yep.
And we're actually looking at how can we take that technology and integrate it in more and more and more of our products, because it is so much better for testing and use. It's one of those things that when we first did it, we learned about it from the RF guys, because they're trying to create spectral purity with their waveform generators, and that's all they focused on. But this was one of these that I didn't get involved in, but it kind of showed what can happen. One of our guys from the team that develops function generators actually went to California to our RF site and learned about it at a lunchtime conversation.
Right.
And he said, oh my, and he was...
I'm stealing that.
Yeah.
Yeah.
He was smart enough to realize what it could mean for function generators, brought it back. It takes a ton more FPGA.
Yep.
And in fact, in our 120 megahertz part, we actually had to do the waveform in pipeline in 4 paths to get the gigahertz sample rate. Because FPGAs don't want to run past about 250.
No, something like that.
And we couldn't afford an ASIC because the volume on the high performance one is lower. So he actually figured out a way to pipeline the whole thing as 4 paths and then mix them all together with a delay line at the end.
Nice.
And it gives us just an incredible benefit. And some of our competitors have picked up a little bit.
I was going to say, Siglin of they do a one that they claim is innovative. Is that just a copy of?
No, it's not a copy because there's nothing to copy. We don't tell you what we did.
No, but the intention is that they copy the intention.
What they've done is a much simpler version that is not as sophisticated. It's a good solution. It's not as good as what we've done.
This allows you to generate small duty cycles in a large memory.
Right.
Yeah.
No, what Siglin's done, I believe, is just basic interpolation.
Right.
Okay? We've done is much more sophisticated than interpolation.
Mm-hmm.
It's much lower distortion, much lower jitter, much more fine-grained. And we're not telling them what we did because once we tell them, they could do it too.
Yeah.
Although it was interesting, like I said, in the high-frequency function generator, once they knew how to do it, because they did it on the lower frequency one, it's just one path. The hard part was putting it in a giant FPGA and figuring out how to do 4 paths in parallel and then line them up at the end. Mm-hmm. That was really pretty tricky stuff. But that's the kind of stuff, when you say digital, I don't think we've even really come close to fully fleshing out all the things we can do digitally to make test and measurement equipment even better. I mean, I think the scopes, they're doing spec hands now, that's an example where they're saying, hey, what's the difference? And we're doing more and more and more of those kind of things. Mm-hmm. What you're going to see next is you're going to see where if you have 2 voltmeters in a function, you have a low-frequency network analyzer.
Yes. That's right.
But you can't do that today very well.
No, it's a bit clunky.
You can't synchronize the 3.
Yep.
You can't synchronize the thing, but there's no reason you can't. In Pixie you can do it, but then you don't have the positive user interface. You don't have it all linked together. So there's a lot more to come.
How would you link them in a technical aspect? How would you link them? Like, would you link them through the network interface, or does it have to have a dedicated physical?
Well, we developed a technology
between
called IEEE 1588. Many years ago. We actually developed it in our labs and then gave it out to the world for free like we did with GPIB. 1588 is time sync over LAN.
Right.
And it's used for video. It's used in everybody's house. They don't realize it. It's used for how they do streaming video in your Apple TV and stuff, and how they distribute streaming video in the cable companies.
That was Keysight or Agilent?
That was developed as, I think, Hewlett Packard.
Oh, that was HP.
It's been around a long time.
Wow, okay.
It was one of those deals when we did GPIB, you have to pay $1 to get a license so you know you're out there, but that's all we did. I was a little bit miffed when I found out how much we gave away on it, but it's now built into all the microprocessors and LAN and stuff. We've developed a method to take it a step further where we combine it with an FPGA and we can get picosecond level synchronization with 1588.
Over the network?
Over the network.
Wow.
Okay.
How do you get picos? Is that another trade secret and you're not going to tell us?
Trade secret.
Damn it.
I can't tell you, but it's pretty amazing stuff what the labs guys have come up with. The problem with 1588 is if we just put it in our products and told you figure it out, it would be so complex they couldn't. I mean, it's really difficult.
So you need the application layer to do it?
You need the application layer to do it, and frankly, one of our weaknesses as a company is our software has not been up to snuff.
Hence your new
Right, so now we're renewing our focus on software and really putting a lot of money and time into software so we can start getting out some of these higher level solution focus. The big term in the company today is solutions, not hardware.
Got it.
Software, not just hardware. It's hardware, software, and people make solutions, and that's really what it's all about.
That's what I was doing the other day. I was characterizing a power supply on the bench, and I wrote them all down by hand. I did because I couldn't be bothered figuring out how to automate them. They're all got LXI connectivity and everything else. I'm not going to say, but if there was a solution that I could just download from the website, just tie these together, and it just worked. Yeah, I would have used it.
It's going to take us a while to fully flesh out that outcome, but that's in the path we're on.
Yep.
There's no question about it. That's really where we're going, because that's the kind of problems that people face today. They don't have time to figure this stuff out. And you look at the emergence of IoT and 5G and some of these new emerging technologies, there's going to be more electronics in everything you own. I mean, everywhere you turn, from when you walk in the room, the lights turn on because there's a sensor that senses you coming in and all that. That's just the beginning. There's so much more that's coming with all these new emerging technologies, and they just don't have the time to do it the old-fashioned way.
And they're often non-engineers.
That's right.
That's a really doing good design,
that's
right?
A really good point.
It's just like
they're gluing together Arduinos or Raspberry Pis and stuff like that, and
and they're doing amazing stuff because they're using all this off-the-shelf hardware and software.
But how do you characterize that stuff in more complex ways? And that's really the challenge for us, is to create higher level integrated solutions with multiple boxes to make it happen. And it's a huge challenge because it forces us to stop being little sites that develop independent products and start creating like one Keysight. And that's why our management team has really shifted investment focus dramatically toward the software, toward the solution side, even to the point of how we market and sell our products. We now have what we call solution teams and centers of excellence. And I'm responsible for a third of the company as the technical side of centers of excellence, and my boss is the manager for all this group. And we have 4 solution teams tied to key industries. Right, so we have one automotive and energy group, we have one general purpose and education group, we have a wafer test, semiconductor test, and board test. And those groups just focus on solutions in those industries. And automotive is, I think, one of the most fascinating ones, because let's face it, 10 years from now, you're going to be reading a book where the car takes you where you want to go.
Right.
You know, it's only a matter of time till that self-driving vehicle. And the technical challenges behind autonomous vehicles are just, it's off the charts crazy.
Yeah.
I mean, and what they're going to do to, you know, Google and other people are doing these self-driving vehicles that they map everything out. And you know what they're finding out? They're finding out that it don't work so good.
Yeah.
And when it's raining, when there's construction, you know, solving those problems is incredibly difficult. And relying on networks to go back to central computers.
I was driving across Sydney Sydney is impossible to drive in at the best of times. It's just terrible. But I was driving home at night. It was torrential pouring rain. And it was construction everywhere. They're chopping and changing lanes on a daily basis. And I went, no, like, this is just a nightmare from a self-driving car point of view. It's just terrible.
And they know that, but they still, this is an enabler for them to sell you an even more expensive car, or even, you're going to rent time on a car. The car's going to get so expensive, we're not going to own them, and they're going to have, how do you feel about a car that the other guy didn't put air in his tires? When you're driving at 200 miles an hour in an autonomous driving lane.
Yeah.
So a lot of things are going to change in ways that I don't think people are ready yet for. But the technology that's going to emerge, because that's what people want, is going to be crazy.
Do you think it's going to take longer than most people think? Because everyone's talking, oh yeah, it's going to be here like that.
I think in limited areas it's going to be sooner, but I think it's going to take longer to get all the bugs worked out. One of the things they're talking about now is that they probably have to put transducers in the road.
Oh yeah, no, once you get to that level, it's...
Well, they're going to turn the HOV lanes are going to become auto driving lanes. That's going to be the first place they say, and you're going to see it. They're going to repurpose the HOV lanes, and you're going to pull into like a gating area with an entrance ramp. The car's going to stop, and then it's going to pop you in at speed. You're going to be tailgating the car.
Got it. You know. And then
So you break the wind barrier, so you get efficiency at higher speeds. And when it'll be like airplane crashes. When an accident happens, a lot of people are going to die, but it'll happen very infrequently.
Very infrequently, exactly.
That's going to be one of the most amazing transformations. That's going to change everything we know. But even the way that electronics is in our lives, one of the things that we've been looking at is counterfeiting.
Right.
You know, Ray-Ban sunglasses, the biggest brands. 60% of all Ray-Bans are counterfeit.
Wow.
Okay.
Yep.
So they're talking about putting electronic chips in every pair so that they can tell if it's counterfeit.
Yep. But then they can just copy that as well.
They're always
it gets harder.
It gets harder and harder.
You're trying to be one step ahead.
That's right.
Yeah. Is there a point where that one step ahead thing, you're better off giving up and just figuring out a better way to...
Well, how do you feel about taking medicine when it's fake?
Let them
give up,
exactly.
right?
No. True. Well played.
Pacemakers.
Right.
No, I have an artificial pacemaker, but it's fake. Yeah, okay. You know, so there's some security issues that you may not want to ever see a fake. But there's problems in that area too, with drugs and food, and you know, they're talking about putting you're going to get meat and it's going to have a tracer in the meat, and you're going to swallow it and you're going to take it out the other way, and that's what's going to happen. It's insane.
Do you expect to ever see? Have you ever seen an actual HP Agilent Keysight clone, like an actual? Do you expect to ever clone? Like 100% clone? It's got the badge and everything. It pretends to be a Keysight.
We haven't seen 100% counterfeit. We have seen in a few cases, I know in the power products, where someone took our PC board, depopulated it, put it on a Xerox machine, and copied the board layout, including our logo. And they were so small, they were selling so few that we didn't go after them, but we had several patents in that product. We could have taken them out very easily, but it wasn't worth the cost. They weren't a threat. We have had other people do, you know, the front panel looks identical to our product.
Yeah.
Certainly the functionality, there's someone cloned 33-120.
And the menus are I did a video showing the difference between they're practically identical.
So what's interesting on that one is the function, if you take the help screens are copyrighted. And they knew not to copy verbatim the help screen, so they changed every fifth word because that gets around the copyright. And inside, it's not the same function. It's not the same.
No, it's totally different hardware.
Totally inside, but the front panel, the screens,
the user
menus,
interface is
it's identical. And that was a very, very good user interface for its time.
Do you think there's possibly code copying going on there, or do they simply write it from scratch and use it as a visual template?
We see much less of that because that requires a lot of work to do. You're taking an assembly.
Oh, you've got to disassemble it, and it's almost impossible to.
It's not impossible,
right? But it's a lot of legwork.
You put enough monkeys at a typewriter, Shakespeare will come out. But we have seen some people who've spent an inordinate amount of time when they probably could have spent it better developing their own product. But sometimes that's what they want to do. Who for me to question it? We're trying to find ways to keep them from representing themselves as being us. That's really the challenge.
Got it. Is it flattering? Is it part of it flattering? Oh, our UI is so good that they copied it. Is there a hint to that?
When Samsung copied Apple, it was a little bit flattering. It was also, they lost market. They sued them for $1 billion, right?
Yeah.
So Apple was furious when Samsung stole a lot of what they did. Some of it they had no right to patent in the first place, but a lot of it they did. They created a lot of great concepts. So it's flattering, but that doesn't last very long. The lost business revenue stays around.
Do you see any future for do-it-all products? Like, will you ever release like a meter with a power supply and a function gen and a little scope in it? And
so we are doing that. Our new scopes have function in it.
Oh yeah, they do, but not in the. Oh yeah.
For most people, 3.5 digits.
I guess the 5-in-1 trend and the 10-in-1 some companies are up to now.
We call it the busy box.
The busy box.
The little kid's thing with all little toys in his crib, But the fact is, that's a more productive environment for people, and you already got the scope hooked up to the circuit. Just tell me what the voltage is. It makes all the sense in the world.
But it's using the same hardware, though. Would you make a scope that actually had dedicated multimeter?
We did that a long time
circuitry.
ago. We've had scopes with multimeters built in and things like that. I can't go into some details of future stuff, but if it's a productive environment, we're gonna do it. If it makes sense on the bench and people want it and we can do it well, we're gonna do it.
What if it just makes sense in the education thing? Would you just develop products for education, or
so some of our
is that a big enough market?
The education market is huge. It's one of the single largest markets. The problem is it's difficult to access at a profitable level. So one of our biggest competitors makes a dedicated box. They sell almost at a loss, and they give away their software to run this box. And they basically, we say we get the kids hooked on our drug first. And every kid comes out of school knowing how to use their software. It's a brilliant strategy if you can do it cost effectively. Our company has always balked at doing that. We don't want to spend that money that way, and we've avoided it. We haven't been as successful in the education market because of that.
Right.
Okay.
Do you think that's still the plate and still the case, or?
I think we're always debating how to. One of the problems you have is it's such a big size that you can't avoid it to a certain extent. And there's different ways to access that market. I think that the way that our scopes team has come out with a low-cost, effective product that makes the customer familiar with the user interface that they're going to sell into when they get into the real world, I think is a smarter move. But there's no right answer. I mean, the fact is, as long as it works to carry you through, it makes sense. We need lower-cost products to make education work for us. $1,000 is a big gulp for someone putting 50 of them in a lab. Okay, and we figured out sometimes with aggressive discounts and a special version of the model, we can sometimes get at it, but it's a struggle, frankly.
What about providing the teaching material? Because I always thought that could be the seller.
We're doing that. We're doing that.
Yeah, I know your scope, your educational scope. We
have a different program we were doing with IoT test. We're making some special versions of products for IoT education, where there's actually got a class behind it.
Oh, interesting.
IoT is big for us because IoT has got RF in it. We're the world's largest RF test and measurement company by far, and IoT is rapidly growing, and it's going into all different frequency domains, and new standards are proliferating. It's a huge headache to keep up with it, but if you're going to sell RF gear, you got to be on top of IoT.
I know you're not in the RF group, or you don't oversee
I don't oversee any. I don't oversee any, but I sit in the background and help people become more effective. That's
excellent. How do you see, like, sampling technology has gotten so good these days?
Mm-hmm.
Do you see, like, spectrum analyzers? They're just, like, the sampling technology is so good, you can just sample it straight to digital, and that's it.
Like, we do that up to a certain frequency.
Up to a certain, at what level is it currently? Do you know?
I think we're in a single-digit gigahertz. We're doing
direct, so anything up to maybe Bluetooth 2.4 gig is possible?
That's on the edge, yeah, definitely.
Right, it's on the edge.
What it requires is, because you can't buy A to Ds that go that fast. We develop our own proprietary A to D technology.
It's all custom ASIC stuff.
That's right.
Yeah.
So we're doing that, and because the higher you go, the more you can do. You can get rid of artifacts, but you also have the problem where if you have interference. If you're doing external world measurements, it's a problem because you have sidebands that are outside the frequency you're trying to digitize, and they can overload the front end. So you need,
of course,
effectively, when you have a down converter in the front end, it's tuned. So you take out those other frequencies before they hit the A to D. So you can get better performance with a down converter than you can with direct digital.
Got it.
Unless you put a pre-selector in front of the thing, which you might as well have a down converter.
Yeah, exactly. So it's always going to be a trade-off.
It's always going to be a trade-off.
Right, so you need both. You almost need to have two different grades of instrument.
Well, if you're doing, like, and you can disconnect the antenna and you can just plug it right on the output of the transmitter, then you don't have those sidebands, do you?
Right.
So much.
True.
But if you're hooking it up and picking
off an antenna or something,
then it becomes a problem. So there's opportunity for both.
Manufacturing. You were talking about manufacturing last night and evolutions in manufacturing.
Right.
Oh, yes.
Which is quite a changing landscape.
One of the things, the biggest disruptive change in my whole career has been the transition from electronics being about the industrial market to the consumer market. When I started, the consumer market didn't exist.
Right.
I mean, it was television sets and they were CRT.
Yep.
And they were NTSC in the US,
PAL here.
Yeah, PAL here, and it was really crude. You go and look at an NTSC. I watched that.
Exactly. We thought that was okay.
And that's transformed to where now that, at one point in time we were the largest customer of analog devices. Mm-hmm. We were their number one customer.
Right.
Today we're not even top 20.
Right. Wow.
Consumer is
that's interesting.
Is taken over, and that's growing. I mean, consumer electronics is growing so fast and so pervasive, and electronics in general, all the mechanics in cars are changing to electronics. All the airplanes, all the tanks, all the stuff is electric motors. It's not hydraulics anymore. Okay, gas engines are going to go away soon. Right? I mean, countries are banning gas engines inside their cities. So that's all going to electronics. So that's the biggest change I see is just the sheer volume of electronics, and it's the wave is not even halfway through. To change every electric system to electronic system. Everything, like you take a light bulb, you just put a filament of wire across the line. It heats up and it gets hot and it lights up. Now it's got a electronic ballast that's driving an LED and it's got an RF communication device. So it's just the transformation is just amazing. How much more electronics there is in everything we own, and how much it's changing, and in ways that you look at it today and say it's already finished. No, it's not even close to finished. Today when you buy a light, those are still fluorescent bulbs, right?
No, LEDs. Everything in here is LED.
So, but those light bulbs are in the form of the long.
They're in the original form factor,
right. Well, in a few years, the actual panel, those things are going to be the lights.
Yes.
Because LEDs like being flat.
Yep.
Okay, but you're still using a form factor that's driven from the fixtures and all the things. You take a lamp and you screw a light bulb in. Well, why do you need a screw-in light bulb if it's an LED? They never fail. So you don't need that screw at the bottom of the light bulb. In fact, why do you need the shade around the light? You need the shade because the light bulb's hot and you don't want to get near it and touch it. It's like a guard, and it also diffuses the light. Well, they can make an LED where the shade is the LED, but they haven't yet, but they're going to. And it's not going to be replaceable. When the lamp breaks, you're going to throw it away. So and that's just a simple trite example, but there's so much of the stuff where we've only started to see the changes, and it's going to change everything. In your car, when it becomes autonomous, the whole way your car's laid out, you're going to have seats facing backwards. Because
why face forward?
Why face forward?
Right.
And there's all these ripples that haven't happened yet that to me are what's amazing. It's like the ride is just beginning. We're at just the first. We just went to the first top of the first roller coaster, and there's many more rides that are going to happen, and it's all going to change more than we can even imagine. That's what I find the coolest thing about it.
What are the big changes coming up in test and measurement? Do you have like a vision of the?
I think the big changes in test and measurement, some of this is the synthetic instruments, the multiple instruments participating in a greater solution is one of the biggest things. Software today we do front panels because you can't get good latency.
Yep.
Except, believe it or not, the video gaming industry can't handle that latency. You can buy special keyboards and controllers and stuff.
Yeah.
That stuff, the computer interfaces, 5G has super low latency, so you can control things wirelessly. There's a good chance in 10 years, all our test and measurement equipment is not going to have I/O cables. It's going to be 5G, ultra low latency, and it's all going to be synthetic. Front panels are going to disappear. It's all going to be through software interfaces, and they're all going to be touch and easy to use and all that. Even though everybody likes this and it's comfortable, it's not going to stick around.
It's not going to stick around. You think everything's going
I don't know how long
big
it'll
screen
take.
touch? No more knobs?
I remember when we used to go out to talk to engineers and we'd say, how do you feel about a PC controlling your instrument? And 20 years ago, 10 years ago, they said, no way.
They groan. Yeah.
Now, if you go out and most engineers bench, and it's funny because yours isn't like this. They all have an arm, one of these articulated arms with a flat
I
panel.
used to have one, yes.
Yeah, and then they have a PC under their bench.
Yeah.
And they have a LAN router along the back of their bench, and they pop all their instruments in, and they bring the schematic up on one. I have two articulated arms on my bench in my basement. One I bring schematics up on, and one I don't use it for displaying the test equipment, but I'll bring up like a YouTube video on how to do a repair, and I'll have the schematic there. More and more, PC is part of the bench.
Yep.
So what the engineer said, I don't want the PC controlling my instruments. How long do you think that's going to last?
Right.
So it just doesn't change overnight, and a lot of it is the people in charge are the ones who did it the old way, and they eventually retire.
Got it.
And then when that starts to happen, then people roll over. Next thing you know, why wouldn't you want it that way? Why did we ever do it the other way again? Like we watched NTSC, or PAL or whatever, and you look back and say, now you hang your TV on the wall.
Right.
20 years ago, you bought a big cabinet that was this deep, and you put this big 35-pound, or 150-pound actually for a 35-inch TV, and now you see them sitting on the curb free, right? The TV and the thing that holds it.
How do you feel about knobs? Because even it's the Microsoft. They have the knob that you can just put on top of your Surface tablet, and it, because people still like the tactile.
Yes, and there's things that just work great. How do you deal with that? That's a great question, and they're constantly struggling with that. When Apple did the touch, they started to do things, but there's still things it doesn't do great.
Yep.
And then there was a period of time where everybody had a fingerprint reader to get into your phone.
Right, yeah.
And now Apple's trying to get rid of that and use 3D face. They claim it's going to be great, and if anybody could do it, they could do it. But word's still out. Maybe, right?
Yeah.
So it's going to require evolving and changing and adapting. The knob may never go away.
Right.
Or they may find some brilliant way that you use your hands and gestures. BMW has the gestures in the car now. Have you seen this?
You can just
turn the volume up. You put your finger up in the air and you go like this, and the volume goes up. I don't know. And you can make the screens like this in the air, just like Tom Cruise in Minority Report.
Yes, exactly. Swiping
in the air. You don't have to touch. You just do it in the air. And whether or not that pans out, it's actually safe in a car, who knows? But there's people trying every possible avenue. Somebody's going to break through with something, and it's going to change. Whether or not the knob goes away, or you're going to stick a knob down on your tablet or on the screen, who knows? It's hard to say for sure, but it will change, and it will change in ways we can't even imagine today. That's the best part.
Please keep the knob. I like the knob.
Well, it's not up to me. It's what customers accept. And if we get rid of it and everybody else keeps it and we lose sales, we'll bring it back. Like we just don't get something stupid and change it because somebody thought it was cool.
Right.
But there's always that constant experimentation to try new things and figure out what sticks. Right.
Could retro become a thing in test instruments? Maybe. Could it? Like everyone's going, portable tablet oscilloscopes, and then all of a sudden, no, and then 20 years down the track, everyone goes, no, I want my real knobs and my.
I think there's always,
thingy,
back guard and forward guard and retro and all that. But it's not as big in the test and measurement industry because it's there for a business purpose. It's not a hobby thing. I mean, for the hobbyist, there's certain things that, because they're inexpensive, like you can buy these little tiny scopes that hook up to USB. And they go into your phone. Well, that's great, but how many people can actually use that? It's not bad if you're playing with a Raspberry Pi and on your bench and you just want to play, but to actually get real work done, it's not super effective. And let's face it, that scope doesn't look all that different than a scope, the 1740 you have here. It really doesn't.
Yeah, exactly.
In fact, one of the things that our scope team learned was that they like separate knobs for each of the channels.
It's absolutely.
Because we had scopes for a while that had one knob and you could
no.
And they found out that that just isn't what people want.
No, that's right. Simple stuff.
And in fact, you'll see on the new power supply, we have a voltage knob and a current knob because our feedback was that people, want both.
They don't want to have to press set. They don't want to have to press. I'll toggle it between the. The two.
Well, we like to
Yeah.
joke too, because power supplies are the only piece of test equipment that we make that can maim and kill.
Right.
Okay? So we want people to have a lot of confidence,
Yep.
or destroy your device under test, which can cost 1,000 times more than this power supply.
Yep.
So we want people to be really confident they're getting what they wanted with no surprises. Like, oh, that's 50 volts, not 5 volts.
Yep,
Oh my
yep.
God.
How do you get, because I probably find that the Keysight velocity controls on your knobs are probably the best I've used. How do you choose the right, like you turn it and it gets quicker and quicker and quicker, and like how do you
We make everybody try.
and make everyone try it? And you did, like,
We actually
do you
listen.
find there's a bell curve of people who, like, some, like, do you just go for the center of the bell curve, or do you find everyone sort of converges upon a
Once you get it right,
thing?
and we've had, like, when
It
we
just
first
feels
started,
right?
when we first did it, there was a lot of not so good, and then once somebody gets it on any product gets it right, then we can use that as a model, and we can.
Right.
It's easier. It's much easier once you get it right the first time, but a lot of it is we use our own products.
Got to eat your own dog food, as they say. Yep.
Next bench still works for some things.
Right.
And one of the biggest problems we have is when we get somebody who goes off and develops something and they have 100% control personally of all those details, that we've made some of the worst feeling products. Where they
Interesting.
control everything. When they kind of go off and do
Yep.
something themselves, and then you go and look at it and go, well, this isn't right, and then they fight you because they have control.
Right.
Whereas when
Yep.
you do it more in a team environment, then you tend to filter out those kind of really 3 sigma bad decisions.
That's interesting, because I would imagine that going for the team approach can be, well, going for the individual approach can either be hit or miss. Either it's
That's
a
right.
complete miss or it's a complete win because that person controlled everything.
That's correct.
But is it more diluted with the, like, design by committee kind
Design
of?
by
if you know what I
committee, you
mean?
don't get the highs, you don't get the lows.
Right. Yeah.
You
Yeah.
get in the middle.
Yep.
We had a design we did on our logic analyzers, had one knob.
Yes,
touch
I remember that.
And the guy who worked for them worked for our voltmeter team for a while, and he kept trying to get us to do that again
Right. Oh, on your volt.
on everything.
On everything.
He thought that was the greatest solution, and everybody who used his logic analyzer hated it, but he thought it was incredible.
Right.
Because he was too close to it, and he couldn't see, and
Yep.
he didn't listen to his customers as much as he probably should have.
Wow.
But he kept insisting, and his code is in here. He did the graphics libraries
really?
for all these products. He's a great
Interesting.
engineer,
Yeah, yeah.
but when he carried it all the way to the final UI, it wasn't as good. And
Right.
he was fantastic at a coding level, creating graphics libraries, which, like I said, he wrote all the graphics libraries for all these products. But when you put him in charge of the whole UI, you didn't like it.
Right.
He was kind of that 3 sigma that you probably shouldn't listen to for that.
Yeah. Right.
But along the way, he was like the most amazing graphics guy. I mean, it's literally used in every single one of our products.
Do you find that when it's only developed internally with no outside control, do you get stuck in your box sometimes? You've got your...
So much. That's
Yep.
one of my biggest frustrations. I call it a failure of imagination. You know, it's very much one of my favorite analogies. Did you ever see the Brady Bunch movie?
Yes.
And you know, the father, every time he tries to do an architecture of a gas station or something else, it's his house with a pump in front. And I use that analogy to say, you keep trying to take what you did before and just do it again, because it felt great when you were great at it.
Right.
And that's one of the biggest curses. Our biggest successes trap us. We try to replicate our biggest successes. And the antithesis to that is when I was a kid, you could buy 2 kinds of sneakers. You could buy Adidas Superstar leather, very expensive, very nice, or you could buy Converse Canvas in
Right.
the U.S. And today, if you go into Foot Locker,
Yeah.
how many kinds of sneakers are there?
10 zillion, isn't there? I don't know. I haven't yet.
The fact is, this function of this voltmeter is
Yeah.
very close to what the 34401 did. Yeah, it has capacitance and
Right.
it has
Yeah,
data
yeah,
logging,
yeah.
but it's pretty much the same.
Yep.
And the fact is, there's so many other opportunities to go sideways into
Yep.
different things. And we're looking at that now more. But the tendency is saying, no, we nailed it then, and there's nothing beyond that. And that's just
Right.
not correct. The markets always fragment over time. They turn into multiple different things. And our competitors show us that in so many ways. If you look at that power supply from one of our competitors over
Oh,
there, that's a very different way to do a power product.
Yes.
It's not inexpensive,
No, but
it can do
It's-
things that we
Yep.
can't do with any of our power products.
Yep.
It's very imaginative, re-looking at how things work. And we need to do more of that, frankly. Not get pigeonholed into. I mean, our scopes group is probably one of the best at that. They figured out it was really useful to have a function generator built right into the scope, right?
Yeah, it was the first. Were you guys the first one to put a function
I
gen
think so.
in? I think you were.
And our reaction
Yeah.
when we were developing the function generators was, how dare they do that?
Yeah, right.
Except if customers want it, how dare us to say we shouldn't do it just because we have that charter? The fact is, nature will find a way, from Jurassic Park.
Right.
The fact is, if that's the better answer, we got to get there. Or if we don't, somebody else will. And to put our head in the sand and act like, I can't believe they did that, they're hurting our sales. Well, somebody else was going to do it if we didn't. You have to eat your young. You really have to replace yourself, whether you like it or not. And if you don't, somebody else will.
But with that example of the function gen in the scope, I noticed you did cripple it somewhat.
It's a simple DPS.
It's a simple...
And it's grounded, yes.
It's probably... I know you, later on, you added firmware. Actually, after I complained, I think that it didn't have ARB capability. You added it like 3 months, 6 months later or something in software.
There was a gap. The first one actually came with just pure function generator. Then after that, I think it was about 3 to 6 months, we actually had the full ARB.
The full ARB capability, and that
stay tuned. There's more to come. But the fact is, they were innovative because they actually broke the mold. Now, they had no allegiance to preserving the lines between different products before, and it was a valuable addition to the market. People loved that feature in the product.
Yeah,
okay?
totally.
The mixed signal, which they invented, was now it's all over the place. You can't imagine a scope without mixed signal.
Exactly.
That's like thinking outside the box. And when the people who figure that out are the ones who really get ahead. It's when you pigeonhole yourself into a narrow thing, the world passes you by.
Right.
And that's what we have to avoid. And we've been guilty of it in some cases, and part of my job as a change agent is to shake the tree and keep that from happening.
Awesome. I've got to ask, the MegaZoom 4 ASIC is now, I think I did the math the other day, and it's like 7+ years old. How old is the Keysight? How old is the original 2000, 3000X series now? It's 7? Is it 7 years? It's about, did the MegaZoom 4 came out with the, it came out with the launch of the
2000.
with the 2000X.
It was a project.
Jackal.
Jackal, yeah. And then
Do
Coyote.
you have internal code names for everything?
We do.
Cool.
We do. There was Jackal, Coyote, Wolfhound,
Yep.
and Marsupial. That one's Marsupial.
That's right. All right. Is it written on the board? No, it's in somewhere.
It could be.
That's right. It's somewhere.
Yes. All of our projects. This was Torres.
Yeah. Oh, Torres.
Torres, which is, I guess, the pine tree in the... Or no, it was one of the mountains in Colorado. If I'm not mistaken. It was Torres. Yes, and the func generator was Garfield, because they named him, and Nermal and Arlene from the comic.
Oh, yes, from Garfield comic.
Yep.
Yeah. Wow.
And
cool.
Yeah, each project, that's one of the fun parts is to come up with a name that means something to people on the project team.
Got it.
And all internal.
Are there fights over who gets to...
No, usually a few people are really good at getting names. No,
right,
certain people are good at coming up with names and other people aren't. And my favorite one was one that I got involved in. I developed a product about 20, 25 years ago to manufacture lithium-ion batteries. And I picked a good name, but it wasn't a great name. And we called the project Mufasa, because lithium-ion looks like lion, so it was the Lion King, and it was Mufasa.
Right.
And we were selling this in Japan, and we go over there, and the Japanese said to me, but John-san, Mufasa dies, doesn't he? God, you're right. The project was not successful. So recently, we've been coming into that market again because of the automotive energy market, and we developed a product. And the person I worked with in the original project was involved in the second project, and I was only involved in helping transfer the technology. They called the project G3. And no one knows what that means.
Right.
It turns out he is Italian and he loves the Godfather movies. And he calls it G3 for Godfather 3 when Al Pacino thought he was getting out of the mafia, he was pulled back in.
Right.
So this was just when we thought we were getting out of the lithium-ion battery market, we were pulled back in. It's one of these subtle things you'd have to be part of the project team.
You wouldn't know otherwise.
Yeah, project names are fun. They're not supposed to get out. We've actually had...
it's fun when you put it on the board. I like doing a teardown, and there's some personalised... Please allow them to put more personalised stuff inside.
Well, we had many stories. One of the projects I developed was the 66,000 modular power supply with the plug-in, snap-in, with the displays on each one, and we had a remote keyboard for it. And we hid an Easter egg in the keyboard, but if you held down certain keys, it scrolled the names of all the project team members and beeped the beeper with Morse code, because the guy was a radio buff.
Right.
And we were at one of these internal training events, and the engineer turned on the Easter egg to show it to somebody else. And the beep was loud enough that one of our top managers, who was a radio buff, was going, Ed Gilbert, John Kenny, and he was reading the Morse code.
Reading the Morse code.
And he went, who has Morse code in their product? And he came over, and at that time,
That's great.
there was a big stink because somebody else used like 30 or 40% of the code space to put videos of the project team in the product. And they got
wow.
in big trouble for it.
Yeah,
and we
yeah.
got kudos because we encoded it in Morse code, which is super efficient,
Yep.
and only took 1% of the code space.
Only 1%. How much did the old, because the old HP scopes used to have the,
had
and
Tetris.
I've got one there, which is, yep.
This had
it's-
Tetris in it.
Yes, it had Tetris, and one of it had the Asteroids.
Asteroids. Yeah.
Asteroids game. How much code space was?
No idea how much it actually
right.
takes, but all I remember was we thought we were going to get in trouble because it was right after he got furious because they wasted so much time and
Yeah.
code doing it. And when he realized we did it in Morse code, first of all, being a radio buff made him think it was cool for that.
Right.
But then he said, and you know, it's even better. It's in Morse code, so it's super compacted, efficient, and we didn't get in trouble at all.
Right, so engineers can still get away with that if it's not detrimental to...
A little bit goes a long
Yeah.
way. And
Right,
it does,
okay.
things that make the team feel good about the
Yeah,
project
yeah,
is
totally.
It definitely helps.
Yep.
A little bit goes a long way, though. It's been one of the strange things. The one I always remember the closest is the original Macintosh.
Right.
All the
yes.
design engineers scrolled their
They
names.
signed their name in the case, and it was embedded in the case.
It was embedded in the inside of
molding,
the case.
yeah,
in the molding of the
inside.
case, yeah. So
Yeah,
you can
I've
put them-
got one. Yeah.
Yeah, I made the mistake of buying one at a garage sale and then realizing I didn't want to play with it because it was disc-based and really you
Yep.
couldn't do much with it. Now they're worth like thousands of
Yeah.
dollars. If they
Yep.
still work, they're worth thousands of dollars.
Nah. Anyway, can we see signatures at one point inside?
I guess you could if we molded stuff. I mean, it's like putting your finger in the concrete,
Right,
right?
yeah.
Sure. There's been all
That'd
that
be neat.
different kind of stuff. It's one of the strange arcania part of project development is getting
Yep.
that kind of stuff hidden in the product.
But it's not frowned upon? Well,
It's
at
frowned
some
upon if-
level it will be. At some level you'll cross a line and...
Yeah.
Yeah, okay. But
And
they
it's
still
part of it
see
now, the
stuff.
projects are expected to go so much faster today. One of the things that's, staying up with the competition, we try to get products done in 12, 15, 18 months today. It used to take 3.5, 4 years.
Yep.
And
Wow.
larger project teams and more custom stuff now, we try to use more off the shelf and get it done much, much faster. And the cost of money today is much higher. Engineers get paid much more than they did 20 years ago. So we have to get it done in less time to make profit.
Yep.
And the expectation now that we're solely a test and measurement company is that we can't use any excuses. Oh, we gave all the money to corporate.
Right,
No.
yeah,
We
yeah.
have to stand on our own as a profitable
Exactly.
entity that's growing because we want to be a growth stock, not just a cash cow. So that means we got to get lots of products out because you grow by getting more products out.
Got
If
it.
you're trying to hit the home runs and make the perfect product, it ain't happening.
Right.
I mean,
Got
it's
it.
rare. Every now and then you see one light up the sky, but the home runs happen so infrequently. Most of the test and measurement, it's the next one that's somewhat better, a little bit less money for a little bit more capability. There are disruptive new technologies that come, but they're rare.
Got
They're
it.
much less common.
That gets back to my original question before we got sidetracked. The 2000 3000X series, it's long overdue. And
Well, I would
it's
say it's
almost...
long overdue. We're certainly looking at the next evolution.
Right.
The team is.
that's obviously no secret.
No secret,
Everyone
but-
knows you've got to be working on the
There's
next.
a magic to not doing
Scope.
it too quickly, though, to
Yep.
making sure you get all the
Okay.
value out of the investment,
Yes.
and also waiting till the disruptive changes that your competitors introduce and market needs change. So, because it's a huge expense to develop those chipsets, took over 5 years.
5 years to develop the MegaZoom 4, even though you had the MegaZoom 3. Was it a complete... Would you know, was it a complete
all new
redesign?
ASICs. All new ASICs.
Yeah, but was it a complete redesign in terms of architecture?
Yeah.
Oh, it was.
Oh,
Okay,
absolutely.
from the ground up.
Yeah, the MegaZoom 3, I believe they brought it into a processor to display the MegaZoom 4.
Oh, right. Yeah, yeah.
They have the digital ASIC has
Yep.
a display
Built in.
paints the screen, and in fact, on the higher end Wolfhound product, the
What's the
6000.
Wolfhound? Oh, the
4000,
Wolfhound. That's the
4000
code name. Yep.
They actually use a processor with a camera interface, and they take
Right.
the ASIC's output into the processor as a video,
Right.
and then overlay the higher resolution information. That's the only way they can get a
Interesting.
higher resolution outcome, because
Right.
the chip is hard coded at a certain resolution.
Yes,
So-
it is. Yeah.
So in order to continue to use that chipset and extend its life, they had to do it that way. So obviously we're not going to do it that way going forward. We're going to take it to the next level. But
Yep.
this is a huge part of the scope market. We went from being a smaller player than the attack
to number one. Did you?
We're
become
neck and
number
neck,
one
and of
at-
course our competitors aren't standing still.
Yeah, no, they're in terms of memory space. Like the Keysight still rules in terms of response and user interface kind of, stuff and your speed of updating, that sort of stuff, but lags behind because of the limitation in the ASIC, the amount of sample memory, the size of the screen, as you said, is limited to 800 by 600. You can't get any bigger. You can't.
So they're obviously looking at all that now, and but there's a magic time. You don't want to go so soon that you don't pick up enough update, and you amortize the cost of making those chips, but you don't want to wait so long that you lose. You don't want your markets to grow and then shrink a little bit, because you're better off. So the next growth comes at the peak of the previous growth.
Yes.
Getting that right and not over-investing and not under-investing is pretty tricky stuff.
Got it.
They're clearly working on the next step, but exactly when you're going to see it, I can't get into that. Once you jump up that much in market share, then you have the wherewithal to make that next investment. You've got they've got a much bigger revenue today than they did when they did the first ones.
Yep.
When they did the first ones, it was more of a leap of faith.
Right.
Because they weren't there, and now they're there.
Exactly.
So, but the same, I know that the manager of that whole operation, he cautioned his team not to just redo the next chip so quickly, because they didn't necessarily have enough of the insights that really would do a disruptive change. Okay, and you can't just do incremental small stuff. The investment for that is too high, and you become pigeonholed. You start doing things that look like the last one. You do a Brady Bunch problem. Everything looks like your next last house. To do that really disruptive change, you have to take a deep breath, wait a little bit, and then you really make a big change.
I'd love to know the design phases of this thing. You worked on this?
Yeah.
Yep. Well, you designed the front panel, but you worked intimately on managing. Did you manage the development?
No.
No. Okay.
No. So I'm a technology manager. One of the things I do is I work with teams to create common building blocks that get used between all the projects.
Got it.
And I'm often brought in to help them go over a particular difficult technical challenge. So, for example, on the high-end function generator, they had some horrendous problems with the switching power supplies to power up all the high-power ASICs, creating spurs into the output of the function. Because at 120 megahertz, it doesn't take much to get bad noise output. And I brought in some power supply people to help them redesign all the power supplies to reduce the noise. Because our power supply group is really good at low-noise switching. They were not good at low-noise switching, but they had tons of power requirements because they had a giant ASIC in there, or giant FPGA, I should say, and some really high-current DACs and A to Ds, or not A to Ds, but just high-power circuits. So the switching circuits they put in were like larger than they had ever designed before, and they're not experts on switching power, but the folks in New Jersey are. So I got involved, and I got another guy involved, and we redesigned their entire power subsystem for them so they could stay on track on the project. When they hit a wall, rather than say, you guys better fix it, work 12-hour days for the next 3 months, no, that's not how we're going to do it. We're going to bring in people who know how to do it and get it right quickly so you don't delay the project 3 months and don't burn out. We get it done right and get it done once. So I'll do that. The folks who developed our SMUs didn't know how to do this kind of graphics interface. Right. So I had the team that developed the firmware for this and our hardware design for this, and we transferred that stuff to our Japanese team that did the SMU. So the Mount Fuji project was our new SMU to compete with our folks in Cleveland, and they leveraged all that stuff from the other designs. They used the same circuit designs. They took the schematics and transferred them, and then they built it up from there. That's what I do, is I help make those connections.
So the development process, you need a replacement for the,
401.
34401. Did you come up, what shipped? Was that the original concept? How many what sort of evolution did you go through? Did you go like, we're going to have a graphical screen, it's going to have the graphing, and it's going to have this, and how?
We already had the function generator at that point.
Oh, okay.
The function generator was pretty much the first major product. The counter and the function generator were developed more or less in parallel. So we had the basic structure, but it didn't meet the cost target. So that's when we had to kind of crush it and reduce the cost dramatically, and that's where I got heavily involved. But the DMM technology, believe it or not, was actually we had done a research project on replacing the 3458, which we ended up putting aside, and that team stopped working on that, and then we had them go and do a dramatic cost reduction to fit it in these kind of price points.
Interesting.
And strip it down and simplify it. And then the team, in our Loveland, Colorado site, came up with the voltmeter to make it meet the cost targets. I came up with the new low-cost front panel, and we merged the whole thing together. But this architecture is dramatically different than the 34401.
Yes.
The 34401, the fundamental problem with a voltmeter is that it's isolated. And the 34401 has the entire processing core next to the measurement engine.
Yep.
And it directly controls the measurement engine. And the entire front panel is floating
right next to
the measurement potential. That worked back in the day of GPIB and RS-232 because we could isolate GPIB and RS-232 over very simple UARTs. There's a chip called the ALF protocol, which basically takes and isolates that and brings it across isolation into a custom ASIC. And that's great for GPIB and RS-232, but when you get to USB and LAN, it can't be done.
Yep.
You need processing right next to the LAN and USB because it's all grounded. You can't isolate USB and LAN very easily at the high speeds.
So you changed the architecture entirely to put the processing grunt, which controlled the screen and did all the processing, at the back end, so to speak.
That's correct. What we call the ground potential.
Yep.
So the front panel display also, because this would be floating, that was a problem. Isolating this so it's safe with a flat panel display is a little bit more challenging than with a vacuum fluorescent display. It's a little bit easier to keep the cracks from giving you, shock hazard. So also the LCD display has to be directly connected to the processor.
Yes.
All right, 24 lines. I mean, it's a very wide bus. So all that had to get moved to ground. So they had to develop a whole new protocol to a much smaller set of hardware that controlled the actual measurement engine.
Yep.
So they developed a whole new system to do that for this project, and that's what enabled these products to do what they did, using the same processor platform, for the most part, that's in the counter, the function generator, and our power products as well.
Got it. So we ended up using FPGA for the measurement
There's
engine?
an FPGA and a single chip.
And a single. What's the single chip?
The single chip does the communications across isolation.
Yep. Oh, okay.
And does the slower state machines,
Yep.
and the FPGA does the high-speed processing of the delta sigma A to D. So it does the big FIR filter that basically takes this A to D converter, doing high-speed sampling of multiple bit, and then turning that into a slow, very high-resolution reading.
So cost was paramount. Was it the entire driving factor behind this? So, well, there were two. One would be complete compatibility with the existing product because it was so ubiquitous and integrated into
in test and measurement history.
Largest selling product in test and measurement in your company?
In my
history?
company. Probably in any of our test and measurement companies, because we're the biggest.
Wow.
But the 34401 at its peak sold over 25,000 a year.
That's crazy.
Yeah, we're not back up to that with this, but we're heading there. Some of it is because competitors have come in and taken some away, but and it's still growing. This is still growing quite nicely, but
so there was compatibility and there was cost. Seemed to be the two driving factors. Nothing else.
Well, and also differentiation. We had to add new capabilities. We had to do the new graphics display. We've added data logging. We've added histograms, things like that. Which today
they're very useful.
Exactly. Yeah. But the point is, you got a graphics display. Damn it, use it. And it's not just a different way to control the thing, because the menuing system on the 3441 is not as easy to use as this, but it's hard to justify switching all that just for that.
Right.
So you might as well get more data. And there's more things we'd like to do with the display, but and they did some newer things, I think with the 65 and 70, if I'm not mistaken. They have dual parameter information.
Yes, they do. There is a dual display.
Right.
Yep.
That wasn't in the first one. We didn't have enough time to fit that in.
Right.
They wanted to, but when we got to 65 and 70, they added that. And frankly, with the 34, 410, and 11, they had the dual parameter in a vacuum fluorescent. Yeah. And when we first introduced the more basic models, we didn't have it, and we got feedback that was a problem. They liked the dual display.
Right.
So they fixed it, and they rolled it out in the 65 and 70. The biggest challenge in this was when they developed the 34401, literally they were on the second floor of a building and the manufacturing center was on the first floor.
So good.
So it was very easy to optimize cost and learn how you're going to cost this, what the rules for engagement were to optimize it in the right way. Now this thing is manufactured in a CM, not even in our Penang operation.
Oh, okay.
And the supply chain, the transformer is made in Kuantan, Malaysia.
Right.
Okay? And back then, we bought it from a local vendor, all right? And therefore, optimizing it, the perfect shielding to get the common mode noise, all those things was much easier. You got in your car, you drove to their site, and in an hour you have a meeting, you get the thing in, you got to move the shield this way.
Yep.
No problem.
Easy.
Now it's a third party through our Penang operation back to the States, and getting the cost of it and getting the performance of it is much more difficult. So one of the other things I do is I go to Penang fairly frequently, and they had an issue with the vendor we were using. They weren't meeting the cost. I actually traveled to China to visit another new company because I do a lot of magnetics materials work for people because of our power supply background, and I visited this new company and vetted them out and made sure they could do a quality job and help communicate our technical needs, and they're now meeting cost on that much better than they were before.
Is the reason you went to a contract manufacturer CM for that you were using the terminology there. Is that purely a price point thing, or like why don't you? I mean, you've got your own huge manufacturing facilities.
We do, and it's an interesting story. Some of it, I think, in retrospect, we might not have done. But let me play the whole thing out. First of all, keeping up with the latest surface mount board loading technology. It's very expensive and it's constantly changing. And
But you're not going high density and stuff like this.
well, we're not as high density as some products, but we're certainly using smaller and smaller parts everywhere.
And fine pin pitch BGAs and pain in the butt.
0402s and even
Right.
0201s in some cases, and
Right.
DFNs, which are almost as bad as BGAs.
Yeah.
And we're moving toward 3 and 4 thousandths traces and spaces.
Oh, okay.
Things get denser only because that's what the packages are coming out in, and they're smaller, and you're trying to fit more functionality in less space. You have to. But the point was, our company made a decision to get out of board manufacturing because we got back out after it just went surface mount, and the equipment was already starting to evolve and change, and keeping up with it and doing it in a quality way. And as Rojas happened too, we didn't want to make that investment.
Better off leave it to the
You can buy it,
experts.
okay?
You can buy that service.
So we moved the boards out, and when we moved the boards out, we still did the assembly of the final product in our own site in Penang. But then we were still part of and this is kind of a related thing, is that we were still part of Agilent at the time.
All right.
Agilent was still building their life sciences products in the States. In fact, in Delaware and a few other locations. And they looked at our cost of manufacturing was much lower in Penang, and they said, we want to move that stuff to Penang.
Oh, no, they're about to invade.
Well, our factory is only so big.
Yeah.
And they said, you guys got to move out to make space for them to move in.
Oh,
Okay,
goodness.
so we basically we went to the CMs who were building our boards and said, we want you to build our products. And they said, that's no problem. We have your business. And we started to move a lot of the products out of our local. And the idea, too, was to lower our indirect overhead. They were more efficient at manufacturing because they do a whole lot more of it than we do, and it was even less expensive. And also, one of the other benefits is that they often have small shops in the U.S. that we can work with for prototypes, even at the final product level. And for some products where the volume is very small, we would just stay in the U.S. So we could do more localized manufacturing and get quicker turnaround and faster response time for low volume specials and high value products. So we made a decision to move our manufacturing out of our factories to local vendors right in the Penang area or down in Johor and places like that. That created some challenges, some transition challenges. We're not completely through that, but we're mostly through it. Most of the stuff is moved out. Some of the very old products we didn't move because we're not going to keep them for that much longer. So if you go in Penang now, you'll see production lines for our products, but they're mostly the old through-hole, older stuff that we don't want to spend the money to move it because it costs a fair amount of money to transfer all the test sets and training and all that kind of stuff to other people. So one of the challenges for this was introduced as we were starting to make some of those transitions.
Right.
And we were still able to keep it. We tried to do the new products in our factory and then move it at first. Now we do direct to CM. The new products go right to the CM first product. This product was still built in our Penang operation and moved out after it went into production. But the newer versions of the product are going right to the
I noticed that. I've got one of the original made in Penang ones. Yep.
Well, everything's made in Malaysia, but not all that stuff is made in our factory. So it's an interesting challenge, and I think the CMs have been exceptional, frankly, at doing a good job. It still takes a lot of scrutiny on our part and review and keeping the quality high, but these are big corporate companies. They know how to do a good job, and we think the flexibility long term is going to be good for us.
Excellent.
Being able to move things around, if a customer needs a special and they have a facility, one of the three, I'm not going to name all the CMs we use, but is really good at transferring between the different sites. That's one of their skills. And we're seeing that as a potential way for us to respond quickly for modifications and specials and new needs. So we'll see how that pans out. Some of these things, I wouldn't do myself. I'm not saying this one is or isn't, but this one's worked out okay. And our goal is long-term is to lower cost and get more responsiveness. Yes.
Back. Do you know what the issue there was?
Absolutely.
You do. Tell us.
Very interesting story.
Tell us the interesting story about how this was respec'd. It came out at 1,000 volts, spec, and then did somebody realise, or did you guys realise that there was an issue?
There wasn't an issue.
Oh, there wasn't an issue. It was a bit blown out of proportion.
A bit blown out of proportion.
Okay, do tell us anyway.
Okay, so what happened was we had a customer who was very interested in our voltmeter to reduce the amount of calibration they had to do, and they wanted us to create a custom version of it they built into their system.
Oh, and you would do that for a big enough customer?
For a big enough customer that would pay us enough, sure.
Right.
And it was also strategic in that we wanted to learn more about their needs, so sometimes we justify things by saying this is a door in to learn more about their needs. And in certain growth areas, we like to do that. And the team that was going to do that was in one location, and they took the design of this and they were going to reform factor it into a card that went in the customer's system. So they're going over the design, effectively doing a complete design review, and they noticed that one of the parts in the design, the voltage across the part was above the rating on the part.
Which part? Do you know? Or
I'm
you
not
don't-
going to say.
You're not going to say? Okay. All right.
And
All right.
what happened was they said this is unacceptable and we can't do this, and they said it's a safety issue, which it wasn't, and they alerted some people, and
panic ensued.
And panic ensued, and the knee-jerk reaction was to make a change to cause safety first.
Change to the spec. you
Change
mean?
to the spec and say
Yep.
don't do that, because
Yep.
we said this could be a safety issue, and the reality was that upon further review, it was not a safety issue.
But you did publish the spec, you did revise it and published it, and hence why it was noticed by people on the forum.
Oh, big time, sure.
Yeah, yeah.
And it's
Right.
not a safety issue,
Right.
and the part is acceptable to use in that application that way, and we since then have pushed it back to 1,000 volts.
And so you've changed the spec back and everything's hunky-dory.
Yes.
So
but
there
it
were
was
no changes made?
no changes made.
Right.
New people
Okay.
looked at it and said, this isn't
Right.
right, and it turns out it was right, but people, it's one of these things, we've done it that way for so long, no one remembered anything about it.
Right.
But it turned out one of the things that got it back to the right was we took our competitors' products, they did it the same way. Okay, and then finally the people who had not looked at this in a long time said, yeah, maybe we need to rethink, is this really wrong, and figured out it wasn't wrong,
Okay.
and it's back on track. You know, we don't get everything perfect every time.
Sure.
And there's such a complex set of situations.
Yeah, yeah.
Safety is we take very, very, very seriously. So I say if we're going to have a knee-jerk reaction, I'll take it there.
Right.
Okay?
Okay.
And unfortunately, it did upset people, and it was a mistake, and we undid it.
Yep.
But, we
And
did-
everyone's happy with it now? Everyone accepts your explanation? Well, then maybe they will now.
I don't know if they're looking at this, but that is what happened, and it
Yep.
was unfortunate that it caused a disruption and wasted our customers' time, wasted our internal time. But the fact is, you get judged by when you get it right
Yep.
at the end. And,
Yes,
and
exactly.
we're sorry that we accidentally thought something wasn't as safe as it really was,
Yep.
but that's
But on the cautious side,
right.
yeah, a lot of companies would have just, oh, don't worry about that.
We probably could have gotten this one right sooner and not had the
Right.
disruption.
Okay.
But I think it was a little knee-jerk on our part, but if we're going to do a knee-jerk, I'll take it here.
Yep. Okay.
So that's what
Interesting.
happened. I was actually involved in that.
Oh, okay.
Because
Right.
power supplies have a lot of safety issues, especially
Yes.
switching offline power supplies. So I was pretty familiar with it, and I was one of the people that knew it wasn't a problem.
Mm-hmm.
But certain people thought there were too many opinions in the room and told me to stand down, and I said,
Right.
okay.
Okay.
And it finally came around. You know, I'm not saying I'm glad I was right. I'm glad they got it right.
Yep.
That's what matters.
Right.
It wasn't one of our best days.
Got it. But it all worked out well.
Yes.
Excellent. Say, compliance, the CAT testing and stuff like that. Not so much the bench meters, but very important in handheld
Absolutely.
meters and things like that. Have you ever sent something away that's, like failed and they've come back and say, hey, this is not going to pass or something like that? Or do you guys always get it right first time? You're so
No, we
experienced
don't get
at
it right the first time.
No?
It's a challenge, and frankly, the new IEC 61010
Yeah,
that
it's
we
a new
comply with is much more challenging.
Yes.
One of the subtle things.
What's the major change for those?
One of the
Do you
biggest
remember?
changes is that you have to anticipate likely mistakes the customer might make. And
Right.
If that causes a safety hazard, it's a problem.
As in operational mistakes,
Everything.
probes in the wrong, everything?
Probes in there. So, for example, on our new power analyzer, which can measure 1,000 volts
Right.
and isolated 50 amps of current isolated
Wow,
from the
yeah.
1,000 volts, we have BNCs for the current input. If you want to put an external transducer on the
Right.
current input, and when we went to put the triggers that are at ground reference, we can't see because they could plug the 1,000
Yes.
volt isolated thing onto the BNC.
Onto
You have
the
to use
shell
two different
piece.
connectors.
Yeah.
You know, you can't just put a label on the back saying don't do that anymore. You have
Right.
to anticipate likely
Wow.
mistakes, and it still has to be safe. We could have had it hook up to there if we made it a 25 amp BNC.
Right.
Okay? That's the kind of thing that's going to start shifting us into
Yep.
new ways. You can't just put a label saying if you're stupid you're going to get hurt.
Right.
It's not good enough
It's
anymore.
not acceptable. It won't pass compliance.
That's correct. And that's
Interesting.
relatively new, and
But that's not a bad thing.
no, it's a
No,
smart
that's a
thing.
good thing.
It's a smart thing,
Yeah.
but certainly something that you see examples where that was the way you handled it. You just said, oh, can't we just put a label? You don't do that. And
Right.
You can't just put a label anymore.
Yeah.
We were having an issue in certain of the power supplies where the binding post could only handle 20 amps.
Right.
And we're gonna have 40 amps. So
Yep.
what do you do? Well, if they pull 40 amps out of a 20 amp binding post, it melts.
Yep.
And it can create a hazard. It's hot to touch,
Right,
can burn
of
your
course.
hands. So we can't do that anymore. It used to be
Uh-huh.
just, we'd put a sense leads on the front panel that say, 20 amps max. And that was
and
okay.
then it throttles it.
No, there's no throttle. It just says don't do that.
Oh,
don't
right.
pull more than 20 amps out of this.
Okay.
That's not acceptable anymore. It was up until IC, the Rev 3 of the IC 61010. So those are some of the standard challenges. And one of the other things we did many, many years ago for our power products was we switched from an offline system to a 48-volt grounded system. We use a distributed DC system. And that's made safety a lot easier to meet for us and shortened development times, because even though our output floats a lot off ground, say 240, our input is only 48 volts and it's grounded.
Got it.
As opposed to being 400 plus with a PFC front end. So that's actually simplified safety for us a lot and shortened development times and made our performance higher. And that directly because we found that the time was taking to all that primary related circuitry to pass safety was increasing test times and compliance testing and certification dramatically. Now we buy a pre-certified brick, if you will, that handles all that thing. And you're seeing that with a lot of other products. They buy these choke snake things, or the phone charger type solutions for low power, and all the safety's inside that charger.
That's right.
And that makes things a lot simpler. You're going to see more of that for low-cost products. You may even see it for a low-cost voltmeters.
Interesting. Okay.
Because it just, to do all the compliance testing and the cost to do it it's quite a bit higher. And those choke snake things and the little plugs in the wall for the phone chargers are getting higher and higher in power.
Yep.
Then nowadays you can.
Oh, it's crazy.
Your phone, your phone can take in like 60 watts.
Yes,
now.
it's madness.
For a quick charge 3, it can take in like 12 volts at 5 amps or something like that. So you can get little tiny plugs that can put out 100 watts in a 1-inch. That's more than enough to power a voltmeter.
Oh, easily. It's crazy. Speaking of power, does standby power consumption, you mentioned power factor correction, all that sort of stuff, is that a big deal in test and measurement? Is it a requirement?
It's not a requirement.
It's not?
It is something we care about. I know the new one we just came out with, people are a little upset because the power when it's off is not really off. And we're actually working on the newer ones, and we're going to make it lower.
The newer what? Which product? Sorry?
I can't tell you.
Oh, okay. All right.
We're continuing.
Oh, this is an internal, still under development.
Still under development.
Right.
We're continuing to refine that.
Right. And somebody internally went, hey, this is drawing X amount of watts.
Well, they noticed the fan was spinning very slowly.
Oh, okay. Right.
They noticed the fan was spinning because we don't completely turn power off. And it turns out that we use a PWM fan, and PWM fans can make the fan go much slower, so it's quiet.
Yes.
But they never stop completely.
Right.
So in new designs, we have to get a switch to turn the fan off, so you won't notice it spinning, because it's not. So just a little nuisance, if you will.
So there's no requirement if a scope has a power factor of 0.5 or something. You don't.
Well,
is that
nowadays
something that worries you?
full power PFCs, even low power, the PFCs are available down to less than 100 watts. So it will have a power factor. Almost any product today will have a power factor of 0.98 or 0.99.
Right.
It used to be PFC was only used at 600 watts and up. Now it's even a 45 watt brick has PFC.
Right.
Yeah, because the chips have gotten so cheap, and it actually above a certain power level, it's actually cheaper to have PFC than not. The components. The amount of loss savings in the parts makes up for the extra cost of the circuit. You can get a PFC, the whole PFC fits in a single little hybrid that they make for 50 cents.
Oh, really?
Yeah, it's super cheap now.
That's great.
You still need a choke and things like that, a little bit bigger input filter. But no, we do care about power efficiency at full power. I thought you were asking about energy
I'm
storage.
at both. It's a two-part question.
We are interested in getting the power lower on the bench. People do not like when it sits there and consumes a lot of power.
Yeah.
But there's kind of a threshold of about 10 watts. Energy Star is like a 10-watt number in the U.S. I think there's equivalent in Europe that they like it to be below something. But it's not regulatory for test and measurement equipment. It is for consumer products. It's against the law for consumer products.
Right, so test and measurement gets a free ride.
Well, PFC we got a free ride, but we still pay attention to it because it's a free ride for us to get it. So, right. But we do have to pay attention to it for standby power because people don't like those big ugly push switches. Are pain.
What do you mean big ugly? I like the big clunking power switch.
It takes a lot of space up.
Yeah, I know. You've got to have a plastic rod to go back.
Those break. You wouldn't believe how easy those things break and how much money
they do. I've broken a few doing teardowns. Yeah.
So, not even teardowns. They break during assembly.
During assembly. Right. Or maybe then get a bit brittle and then break in the field.
That's right.
Right. So we're doomed towards.
We're going to more soft switching for sure.
Soft switching.
Well, it also helps boot times because we pre-boot. It's sort of waiting. It's halfway through the boot process, so you hit the switch, it comes right back up.
Right.
But it does draw a slight amount of power, and we're working to get that lower and lower over time.
How low can you get? Like, what do you have? Like anything under a watt because it's a nice round number, or?
Well, what limits it is because we're using brick supplies.
Right.
This is using a transformer, which means that the transformer is engaged and the power supplies on the output of that are engaged. So this is actually, there's a limit to how low we can get this, but with the little supply, the brick switching supplies, they actually are designed for consumer products. So they can often spec, they go less than a watt when they're in standby. And then they have a small power supply that comes out that keeps a little bit of circuitry alive. No different than your TV has just a small amount of circuitry.
For the infrared.
For the infrared to detect you want to turn it on. So that architecture is slowly seeping into our products to minimize the power. And you can get those down to like very, very low, like 100 milliwatts or something like that.
Fantastic.
Yeah. That one button is separate from all the other buttons, basically.
Speaking of the competitors, yes, like especially in the power supply market, I mean, it's ridiculous what you can get for, like on you can get a bench power supply for $50 on eBay, including delivery probably. Right? No, maybe not.
About that,
because they're still a bit heavy, unless they switch mode.
Box is $8 to switch.
But it's just crazy. Are you like, at what price point? At what price point of instruments will you not go on? Is there a price point where you'll go, look, we won't bother?
Today, there's probably a price point that's 500, something like that. You can see the new scope starts at 500. But that's just a temporary situation. Our long-term goal
is to go lower?
Go where we need to go to be effective. Now,
interesting.
If someone makes something that we don't think customers should have on their bench because it's going to cause more problems than it's worth, we won't go there, obviously. Just because someone else makes it doesn't mean we want to put that product out. So that $25 product may be fine if you're powering up a non-electronic load, for example, but it's going to have tons of ripple. It's going to be slow. It's not going to necessarily be reliable. It's not going to be easy to use. We're never going to make that product, to be honest with you. But there's no reason we can't do a $500 product, as evidenced by the scope.
Of course.
We can address those spaces. In power, in everywhere. It takes time for us to turn our organization around to really get the efficiencies and the infrastructure we need to be effective. But we're on a path to do it.
Awesome. Is there enough margin still at that low end?
There is.
To make it, or do you have to make it up in volume? Like, you obviously volume's the point.
Volume makes a big difference. Common design, common parts, and excellent engineering.
Got it.
It really requires some of the best engineering. It's actually, to me, just like you're doing a 6.5 or even an 8.5 digit DMM requires some of the best engineering in the world. Low-cost product design is an art unto itself.
Component obsolescence.
Big
pain in the butt. Big issue.
Pain in the butt. It's total wasted effort. You already got a design that works. You can ship it, and you got to spend money to make it continue to ship. And the problem is, anything you change in that digital domain, you have to repeat all the testing, all the environmental testing, RFI, ESD, because the new chip could be sensitive when the old chip wasn't.
Of course.
That stuff costs big bucks. And strangely enough, you may have tested it last time and gotten lucky. And didn't know, and then you tested it the second time and had nothing to do with the change you made, and you failed. Just because last time maybe they changed the test setup slightly, or the units you tested last time were a little less sensitive, and you fail and had nothing. So you end up fixing it something that wasn't what you started out to do.
Wow. Most common parts that go obsolete.
ROM and RAM.
ROM and RAM.
By far.
Because DDR has registers that you've got to write specific.
DDR has registers you have to configure, so you have to change the code sometimes to change the DDR.
Because I would have thought, it's just pin compatible, right? They're so jelly bean.
Sometimes it is, but you still have to do all the testing. And then sometimes it is, and you have to change the configuration for the DDR. That's one of the ones we run into. The other big one that's been a big headache recently was, and I think it's more of a glitch in time, was FPGAs. One of the two big FPGA vendors moved their foundry from one company in Taiwan to another company in Taiwan, because the first company, I guess, wasn't working for them very well, wasn't on the latest and greatest technology. And they decided they didn't want to build anything at the old company, so they started obsoleting a lot of their parts that were making in the old company. Well, it's extremely painful to change FPGAs. The pinouts never the same. The older FPGAs weren't done with full HDL, they were schematic based, and the new tools don't want that, they don't accept the schematics. And the documentation on an FPGA is never good enough. You can just hand it to someone else. You get the original engineer involved if they're still around, and it's just, we've spent a lot of money and time doing it. We're getting good at it, but it's never fun.
Do you have to get? I've worked in industry where we have to get like a written guarantee signed by the CEO that they will keep this part alive for 10, 15, 20 years.
We don't do that. We buy large quantities when they tell us they're obsolete.
Let's do a last buy.
We do a bridge buy. The problem is our products, the test and measurement industry and power supplies in particular have the longest product lives.
Yeah, of course, 20, 30 years. It's like,
Now, The newer product families for this particular FPGA vendor, since they've moved to the new foundry, they're moving out the lifetime date they're going to make them for, because it's working very well for them and they're not trying to get out of it. But once bitten, twice shy.
Yeah.
So we're taking a more full documentation approach. We're doing more training so people can take over and move the design more easily in the future. Moving completely away from schematic-based designs as much as possible to full HDL, which recompiles in any of the tools.
Right.
So that's going to help us, but hopefully this was a one-time glitch. The analog stuff, there has been some interesting parts that have gone away, especially in like power supply control, regulators and stuff like that have gone away because companies do it for consumer products. Like, they've done a really high volume part for a consumer product, and then they make a better product. They don't sell any more of the old ones, so they don't want to make it anymore.
Right.
We designed it in foolishly, and then we have to fix it. Those are not as big of an issue, but we still have to retest the whole product.
Yep.
And it's a bit of a pain. And of course, it's bad if they're bigger, but most of the time, the switching chips are smaller the next time.
Right.
So it's easier, and they're more efficient, and they work better, and
so there's advantages to do it. Sometimes you go through the pain.
Well, it's never an advantage doing it in the sense that the product's shipping the way it was. We didn't need to change it.
You're
Now we have to spend money and time. So
Yeah.
the fact that it's a little bit smaller, well, the space was there for the bigger part. It doesn't help us.
Right.
Certainly in a new design, we'll move to the newer chip, but when we're forced to get rid of it in an old design, it kind of stinks, frankly.
It's a problem that's never going to go away. Really,
Well,
is it?
it goes away by doing more modularization.
Okay.
And when you do modularization and you put things in the right groupings, we've made some relatively foolish mistakes in some of our products. We group things that shouldn't have been grouped together. So, for example, this product was a good example. This product, the A to Ds and D to As are on the same board with the power supply. So that means we have 5 different versions of this board. So when that A to D changes, we have to we have to
power
build.
board. Yep.
Yeah. So what we've done in the newer products is all the digital control is on a little plug-in board the size of a memory module,
Right.
and that snaps in. And then we actually use that to upgrade the performance of the product. We have different versions, but also when that part goes obsolete, that board is common to all the family.
Got it.
Okay, and that's helping us. So
Nice.
we only have to do it once, and then we just pop it in and do the retest. So making some smart decision about partitioning helps the part of obsolescence quite a bit, but sometimes it's just bad.